words or expressions for search are basically auctioned. So you don't buy a name, you auction for that name, and they have an algorithm that allocates. You say, I want the word boots, okay? And then there are other people that already have boots, or someone else has boots, and you auction for that. And the auction means, and it's an automatic auction, you don't offer money, you compete with other people and get a price. And the price is per serving. What does it mean? Is the price how many times they display that particular ad that you entered, or that particular link that you wanted. And then there is the other part of the search engine, which, of what they serve, that is actually finds based on the algorithm. And a lot of search engine optimization is trying to be here, meaning being the top of the search but not having to pay for it. How many times when you do a search, you go to the second, third, fourth page that you searched? Very little, correct? It really focuses on here, and people started getting wiser and not really totally focusing on the advertising part, started looking more here. And of course, the thing that we all know is that the words that you use matter a lot. And if you don't know exactly what word to use, use a similar word or something that you can come up, and then you look at the responses for a better word. But the whole business of Google is around identifying who you are, or at least what you're interested in. Steph?
Sorry, and so did you say the search engine optimization are those the top hits under the top 3 advertisements?
If Stephanie is a consultant in search engine optimization, what Stephanie is going to do is try to help businesses to be found with the Google search engine or with other search engines. Okay? And they do all kind of cost considerations to decide if it's worth paying for it, or you just kind of, the way you display your website, the words that you put in there, whatever, bring the closer search that you can, bring you more business as you can. Okay, now, so the business of Google is really a business of collecting information profiles. And it's very nice because it's all automated. But the algorithms are kind of secret. And a lot of people have a pretty good idea what the algorithm is, but they can change that algorithm without anyone's permission. And there is a lot of complaining about they favoring, Google favoring certain businesses and et cetera, et cetera. And you see that in the literature all over. Now, let's go back to the reasons that these companies, and we are not only talking about Microsoft, but actually Microsoft is learning from these other guys. Microsoft hasn't been terribly aggressive in purchases, and now they are, at least since yesterday. Now, how many of you used LinkedIn before? Wow. You guys there in the corner never used LinkedIn?
I have very little.
So this is a geographic division. That corner didn't use LinkedIn. This corner, everyone used LinkedIn. George, you never used LinkedIn?
Oh, yeah.
How about you?
I've used LinkedIn, yeah.
Yeah? Okay, so it's only that little corner there. Okay, what's a link? How would you characterize LinkedIn in relation to other social media?
It's a Facebook for the work people. Professional.
What do you think of the interface of LinkedIn? Krati. What do you think of the interface of Facebook?
There's
always changing. There's a constant update to it.
So if I would ask you, what is your favorite social media? What would you answer? Which is your favorite,
They
Sophia?
have different purpose.
Oh, different purpose. Now we are qualified here. So, tell me your purposes.
Oh, you mean?
What the ones you can tell us?
Different LinkedIn and Facebook.
Yeah. What do you do with LinkedIn?
For profession.
Like look for a job,
Yeah, look for a job.
make professional connections.
Yes.
And what other social media?
Facebook.
Facebook.
Yes, it is for my personal stuff, for connecting with my friends, for finding new.
What's the big advantage of Facebook to connect with your friends?
Stay in touch with past friends from high
Yeah,
school.
but the big advantage of Facebook above the other ones is the number of users.
Yeah.
Facebook is but it's very ethnic. Okay, in different countries, like Kakao is very big in Korea, correct?
Yes.
Oh yeah. How do you know that?
I just was in Korea 2 weeks ago. So.
Oh really? That's interesting.
And everyone,
They
setting
all
up a
use the
meeting,
Kakao.
everything, they say, where's your Kakao address?
That's funny.
Yeah, and in Brazil, they use WhatsApp a lot.
They also have like Russian.
Huh?
There is also have Russian, similar to Facebook. It's also very.
Facebook Russia.
No, like it's different website. It's different social media, but it's also very popular.
Yeah, in China there is a lot of social media that are close to what Facebook is.
In China, Baidu is the one, right?
Baidu is the one. Web chat. WeChat, that's right. I remember last class when I asked you how much do you spend in social media in time, and were you astounded about the time? People spend a lot of time on social media, and that's actually the reason why all these companies are really, number of users is a very important variable in profitability, in survival. Now, what's happening with the Microsoft business?
They're moving into cloud as well.
All of them are kind of putting a lot of things in the cloud. But
They're
do you consider Microsoft the leading edge of technology? It's old technology, correct?
Yeah.
Well, 10 years ago, Microsoft was the top leader. What else is happening in the business? What are the problems that they're having?
They're not as innovative compared to some of their
At least that's the perception. They are not very innovative.
I think everybody has Windows, so they have no room to grow.
Grow.
Yeah.
Yeah. So what are the main products of Microsoft?
Well, they deal more with software as compared to Google and Apple, where Apple deals with a lot of hardware. Google is more of like a search engine and the cloud.
Okay, do you know the history here? First came mainframes, and then somewhere about in the mid 80s, maybe late 70s, some people decided to, they call them hobbyists, assemble, create computers on their own. And a lot of the top companies on the industry didn't think that was a business. And so people were picking up pieces, and developing things like Commodores and smartphones and etc. And Apple, and the Apple I and the Apple II. And Apple basically kind of dominated that market. And rapidly they had like 40-50% of that market. It was just slightly better machine and etc. And progressively it became very clear that PCs would be a very large market. And at that time, Apple came out first with the Lisa. And this was a technology that was like Windows. Before that, the interface was all ASCII interface. You typed in, and the IBM PCs that came in a few years late actually had this thing called DOS, and that was a basic ASCII technology. Basically, you typed your commands, very rigid type of technology. And Apple started with the Lisa. They didn't do very well with the Lisa, but then they did the Macintosh. And the Macintosh just exploded in utility. It just was easy to use, not difficult to access. It was good channel of acquisition. So they had, but actually the technology, the Windows technology, was developed by Xerox PARC. Palo Alto Research Center. And that technology was just really superior to the word interface that you had in DOS. The other part of the story, and so these hobbyists came in, and then Apple came in, and then a few years later, the largest computer supplier, the big computer company, which was IBM, finally realized that that PCs had a future and they had to do something on it. But IBM had this principle: they only sold what they made. So the creation cycle was very long. It took like 5 to 7 years to put the product out. They designed their own chips, they did the whole thing. Okay, and so they actually got this guy called Eskridge, one of the kind of a maverick manager, to say, go over to Boca Raton. Mainly IBM was here in Poughkeepsie, New York, and etc., and create a PC, create a personal computer. And so IBM came out with a PC that had disk drive. You still know what a disk drive is, correct? And no hard drive. It was a floppy disk drive. And what this guy did to accelerate the process and basically break the culture of IBM is he basically decided to assemble pieces from different places as opposed to making it there. So the top maker of operating systems at that time were two: Digital Research and Microsoft. And Microsoft actually had the basic product, which was a language to program it. And they had this operating system called DOS. And to build this computer, they needed the hardware and they needed the software. And the first software they needed was DOS. And on top of that, they were going to put BASIC. So they started looking, and the first idea, let's go to the biggest makers. At that time, there's tiny little industry. And they called up Digital, and it wasn't Digital Equipment, it was Digital Research. And they had a software called CPM, but they couldn't find them. They called Microsoft, and they couldn't find leadership there, but they were all in a hobbyist convention in San Diego. And they had a smart secretary there in Microsoft in Seattle. And she said, hold on, this IBM calling. So they hold on and call Bill Gates in Boca Raton, in San Diego. And so Bill Gates actually just hopped on a plane and went to Florida. And the culture of IBM was suits and ties, white shirts. Everyone had to do that. So Bill Gates arrives in Boca Raton and said, that's the culture of IBM. So he goes to JCPenney's and buys himself a suit. He was in blue jeans, very relaxed. Okay, buys himself a suit, put a tie on, and goes to this meeting. He comes in, sits in the meeting, everyone is wearing blue jeans because they want to make him comfortable. Okay? And so he negotiated DOS. While he was negotiating, selling DOS, and this would be big acquisition because they expected IBM's PC to dominate the market because IBM dominated the market. while he was negotiating that with IBM, he was trying to buy DOS, because DOS didn't belong to him. He was just licensing DOS to other people. Okay, so in parallel, he was doing that, and he did acquire DOS. And at the end, IBM came out with a PC with floppy drives and 2 operating systems, CP/M and DOS. And very rapidly, IBM took a good share of the market with the IBM PC. So that's kind of nice, and they did very well on that startup. But was a very basic difference between that and the main competitor, Apple. And the basic difference between them was that Apple didn't subcontract. So anything that came with Apple had to come from Apple. And because the way they acquired IBM, they acquired the PC, they created the PC, chips were made by Intel, operating system was made by Microsoft, and they didn't have an exclusivity contract. So basically, Microsoft, Intel could sell the same components, the same software to other people. And then IBM started licensing to other companies, like Digital Equipment and a whole set of companies, the PC. And in about 4 or 5 years, basically the market share of Apple had gone to 10%. And then Apple came out with the Macintosh, and that gave a push, but still the price of the device was 20–30% higher competitive devices. So only people that were big Apple aficionados were willing to pay the difference. And there were 10–20 companies like Compaq, like Dell, came in, and they were licensing certain things from IBM for putting that architecture. But the architecture was pretty much open architecture. Anyone could put it together. And at the same time, Apple was tickling around, increasing a little bit the market share. Not increasing market share, selling more computers, but IBM was just totally taking over. At the end, IBM basically sold their PC business to Lenovo. And why? Because the margins were very, very tight. Why they were very tight? Because there were 20 people selling the PC standard machine. And so this is just the beginning of the story. But at that time, Microsoft was, all my students that were techie wanted to work for Microsoft. And before that, all my students that were techie wanted to work for IBM, of course. IBM, there's a book by Catherine Fishman that talks IBM and the Seven Dwarfs. And basically is a chapter. And basically there it shows that IBM was larger than the next 7 competitors in the mainframe business, company like Burroughs, Remington, et cetera, et cetera. And so, what do you think of IBM today? Oh, kind of old-fashioned company. What do you think of Microsoft? Old-fashioned company. Between IBM and Microsoft, there was a company called Digital Equipment, not the one I'm talking about, Digital Research. Digital Equipment made what they call microcomputers, mini-computers, sorry. And mini-computers were kind of smaller computers that were reasonably good for many different purposes, but they were not PCs, the expensive things. They basically kind of went out of business after a while, and they dominated that mid-range. So this is kind of a story, and what is the glamour comes with IBM, the largest one, the techie company. After IBM, Digital Equipment. After Digital Equipment, Microsoft. After Microsoft, Google. Yes. Any other ones? I'll give you some names before that. In IBM, during the IBM time, the other companies that were considered very techy was Xerox. Okay, and you know why? Because everyone knows still the words Xerox copy. Okay, and I can come up with several other ones. But actually, an interesting phenomenon is happening. Oh, I want to ask you an accounting finance question. How come companies like Google, Apple, can buy all the startups at these obscene prices?
They have a lot of cash.
It's true, many of these techie companies hoard cash, but that's not the main reason.
They sell stock.
You are getting there, what else? They sell at very high PEs, price earning ratios. So if you are selling at a PE ratio of 20 or 30, it's very cheap to buy a company that's selling at a PE ratio of 5. So they have to, for them to, what they do is just they issue more stock and acquire the company. And if you think very carefully, these two companies coming together, it's kind of effect with the stockholders. There's a whole set of effects that happen when they coming together. And so many stockholders acquire, get Microsoft stock or Apple stock, and etc. But those are very expensive, working at a very high multiplier. And so it's really the secret why these companies can buy so many companies is that their price earnings are very, very high. And during the dot-com boost, during the dot-com era, the 2003, 2004, actually earlier than, price earnings were bimodal. These were the techie companies, and these were the others. And so what happened that companies like Time Warner, etc., sold out because they want to be classified as techie. Okay? Have you ever heard of AOL, America Online?
Yes.
Okay.
I still own their stock.
You still own the stock? AOL actually was bought Times Warner. Okay. And what happened there?
Went down big time.
Yeah, you know, it's very, very difficult to really predict what's going to happen in these things. My brother used to say, you work on this, I've been working on this for 40 years, why don't you buy tech stocks? And because I knew Amazon when they were just starting, I knew Microsoft when they were just starting, etc. And I just don't have the stomach for this, okay? But it's very difficult to predict because there is a large number of companies emerging, and you don't know which one is going to take off. But when they take off, your increase in value of your stock could be 1,000 times. I remember visiting Dell one time, and now you're not too excited about Dell, but there was a time Dell was an up-and-coming company. They were selling a lot of computers, and they developed this whole strategy of build your own computer. And so you would go into the website and configure your own computer, and then in a week they delivered it to you. And that was very exciting at that time. And they had this whole financial model that they sold your computer, delivered your computer, and then they started paying for the parts and etc. a month later. So they were very ingenious what they did. But progressively their model became generic, and the competition became big. And the stock lost their luster, so the price earning ratios went down. And actually Michael Dell bought the company back, and inside the buyout. Okay, and now just there was a court ruling that he paid too little for it. And of course the concern here is that he willed and dealed, or in any of these cases, and basically cheated the stockholders. And actually, what this judge says that this wasn't the fair price paid, and you know there is not an outcome yet, but there is already a ruling on it. And this is very strange, because the judge is deciding what's the value of a company, and this never happened before. So this is going to be a whole convolution on this buying of these companies. But actually, the reason why these companies are going out to buy is not only that the PEs are very high. What are the other reasons?
I mean, there's enough competition with each other that the antitrust people aren't going to stop them from buying startups.
Okay, there is some limitation of what you can buy. No, antitrust is not going to fight about taking startups. What the antitrust fights is when you're buying a competitor. That's what they really fight. But you're not too far. Well, so why are they buying all these things? Why is Apple buying all these things? Google buys Google's.
I think there's two things. They want to buy their technology. So
Okay, so this is one way. They are doing R&D.
Yeah.
Okay, they are buying new technologies, and it comes out cheap because the P ratio is so high. So that's one of the reasons. What is the other reason? What is the reason that they pay so much for Instagram, for WhatsApp, and now for LinkedIn?
More users, they grow their user base.
Yeah, it became, the name of the business recently became number of users. Okay, and there is a little bit less consideration than should be on the value added per user, meaning by adding Fred to this, to your list of users of Facebook, how much money you are making, or what is the marginal contribution. And what you see is all these social media, basically free, even giving subsidies to acquire people, because they think, although they don't articulate very well, there'll be a value of this in the future. And what happened, many social media, you only think about the successful one, a lot of them bust because they couldn't keep the cash flows going. Okay, so reasons here. Number one, it's cheap to buy because your PE ratio, and you know, people at Google don't think that forever their PE ratio is going to be that high. So while it's high, take advantage and keep buying, and you might hit a new company. You know what? One that I was a little bit surprised is Instagram. Instagram is a real interesting service and has grown, meaning is a major competitor now. And why is that? Cecilia's going.
Because it's the best.
Because they're the best. Yes. They are very compelling, simple service. When you were talking about Facebook, I was going, eh. And I am in Facebook and all these things, but I don't particularly go into Facebook because I find the interface now very complicated, and most of my friends, professors, are not in Facebook. Okay, and so you very much depend on you go to the groups that your friends are in, or you get to your friends in the group. Okay. But most of these companies think that these social media will bring people, and it's not only bringing people, a couple of people you mentioned before, they will bring information for them to use. Now, can you just think of this? So what I'm trying to do here is telling a little bit of history going around, trying to kind of get us synced in what's happening here. Now, one thing we showed is that technologies, even the leading technologies, don't have a very long life cycle. Well, it depends what you call long. IBM was the leader of the industry for 40 years or 50 years. Okay, and Microsoft was the hot company for 20. And Google is the hot company for already 15 years or 10 years, depending when you classify the hot company. Is Google going to be the leading company for the next 20 years?
You don't know.
Hmm?
Who knows?
I'm asking you to tell me. Who knows is not an answer.
I think so.
Huh?
I think so. They're buying so many different companies, and they're already like starting a new, I think, scheme of like creating an internet without wires and all those things. So I think they will be leaders for the next 20 years. I think.
And they have hundreds of businesses.
Yeah.
And they have hundreds of businesses. Why are they doing that? Because one of those might become the hot business. And they also destroy businesses. They buy companies after a while if it doesn't work. They move it over. Have you ever heard of a service which I love and I'm very sad about it? Picasa. What does Picasa do? The Google company.
Where you can store
Yeah, it organizes the photographs in your computer. Okay, and it has a fantastic face recognition device on it. And what I like about Picasa is that it doesn't move my pictures. The pictures are wherever I put them, and it organizes them. And easy to find and very simple, etc. Now they are stopping the Picasa service in about a month and wants you to go to Google Pictures or whatever that thing is called. Now, why don't I want to go to Google Pictures? Because I don't want my pictures on the cloud. It's personal. Can Google do something with your pictures? What can they do, Fred?
I mean, I don't know all the terms and conditions of the contract they signed, but I bet they could probably sell it to someone. I mean,
That's
a
one
piece of data.
And
Well,
do you mind that someone has your picture?
yeah, that's uncomfortable. Like, you know, but if they want to know.
What happens if your picture with your ex-girlfriend falls
Yeah.
in the arms of your current girlfriend?
Think, but yeah,
Falls in the arm of your future girl?
it's pretty bad.
Yeah, it's pretty upsetting. The other thing is, of course, you have a lot of pictures in groups. And what does those pictures say? Who is your group? What's your social network? Who do you see frequently? Can you just, come on guys, you're slow this morning. What else do pictures say that they can extract from it?
the location.
Yeah, location, and now they come with coordinates. Who said that? Steph. What else? Now you know who your friends are, where you were. Okay? You look happy or unhappy. You have a beer in your hand or not.
What your interests?
Huh?
They know what your interests. What are you interested in?
Okay, if you're sitting on top of a horse, it's pretty obvious that you are interested in a horse. Sitting on top of a camel could be that you like camels, or could be that you are touristing the Great Wall of China. Okay, and you can buy a ride on a camel next to the Great Wall. I've done that. I was terrified of falling off the camel, but besides that, come on, guys, that's it.
What clothing brands you wear? Where you shop?
Oh, I always say, you know, you have a shirt which says Lacoste on it. Lacoste should pay you. You shouldn't pay Lacoste, but that's not the way it works. Okay, so it tells you a lot about your wearing. What else?
Your age, to an extent.
Age. What else? Nothing else?
Your political affiliations.
How does that? You're right, but how?
I mean, think about it. Like some people go to rallies and things like that. I mean, they take photos of people or something.
Okay, so now you're interpreting location. It's not about location, but what happens at that location. Good. Secondary usage, but very important. You guys didn't say anything about one very important thing.
When it was taken?
Huh?
When the photo was taken?
Yes, it's the time series of the information. Is you take a lot of pictures in California, then you start taking pictures in Milwaukee, you might have moved to Milwaukee. And if that lasts several times. And then, you had a girlfriend in California, 3 girlfriends in Milwaukee. Or you had 1 girlfriend in Milwaukee, 3 in California, and you moved to Milwaukee. That shows a preference. That's it?
And they can find out, this goes with, friends and stuff, but your family, they can see all the members of your family.
That's right. And is that bad that you know who your family is?
Depends on who is looking.
Depends who is
On
looking,
who is looking
absolutely.
at it, yeah.
My daughter went to Princeton, and she had a stalker. Someone that, I didn't do any harm, but he followed her for 3 years. And my daughter is extremely sensitive about public information. And because that was very scary for her. So are you going to put your pictures on the cloud? Fran goes, yes.
I don't have a choice.
Antonia goes, no.
People have it on their iPhones now, so it's not a crazy idea.
Well, it depends. I always say this. If you're having a great time and carousing with your friends, be careful what you photograph and you post on Facebook. Okay, because 10 years from there, you'll be looking for a job at KPMG. And before Sarah walks in, they go, Sarah, on Google. Okay, and then Facebook, and etc. And will give maybe a bad reputation. Okay, and it's kind of silly, meaning someone 10 years ago having a beer blast with their friends, taking his clothes off, big deal. Okay, won't make him a bad employee, correct? But there is a lot of prejudice about it. So that's how I always say this, is be very careful what you post. And other interesting thing, many of these places like Facebook, etc., has a privacy policy. Have you read any of them? You did?
Yeah, I did.
And what did you think?
What did I think?
Yeah.
It was good because then I could limit the photos that people could see.
You know what I thought you were going to say? You're going to say is unintelligible, the legalese on the privacy policies. I thought that's what you're going to say. But no, it's great that you read it, and some of them are written to be read. Okay, but how many times do I agree without reading what you agree? How about you, Amanda?
I did a lot, but I don't believe in privacy on the internet anymore.
That's what I say. That's what I always say. Privacy is gone. That doesn't mean you shouldn't be careful about what you do on the internet. Yes.
I don't read it because if I want to use this service, I'll have to agree it anyways, and there's nothing I can do about it. And I can choose to not use the service at all, but then.
But all your friends are doing Facebook.
Yeah,
how
and
come
I'm
you're going to say
on
no? I'm
that
not going to use
service,
Facebook?
so I have to.
And you already use Facebook, so how can you back out of the records they have?
Just
on
because I read it, it won't change anything. Unless and they point out all the important information anyways. I try not to read most of them.
Okay, guys, you say, well, why are we talking about these things? This is an accounting class. Why are we talking about these things? This is an accounting class.
Because of sensitive information with income statements, financials, it will be much more readily accessible to especially a lot of the acquisitions that are happening.
And you guys are going to be professionals, and a lot of this is the environment you live today. You have to know a little bit about it, hopefully more than your clients.
Yes.
And in the curriculum of accounting, internet is not introduced in intermediate or in introductory accounting, correct? But that's the environment you're going to be. You'll be sharing files, you're going to be growing as a professional, you're going to be looking for jobs, all these things. So that's very, very important in this environment, much more important than it was 20 years ago.
And isn't it a lot of the firms are not going for the consulting anyways? So.
That's a longer story, we'll talk about it, but firms tend to make more money from consulting engagement than audit engagement. The audit environment is highly competitive at this moment, and is coming back to big emphasis on consulting. Okay, just I want to go back to Microsoft buying LinkedIn. Can we just talk about some financial measures and etc.? I kind of like the list that you come out. Why are they doing it? Okay, now they're doing it because they can. The PEs are high. They are doing because they need R&D, and it's maybe cheaper to buy R&D as opposed to develop R&D. The other thing is they buy companies because the companies already started to market it. So they get a better feeling for, is this going to be a hot product or not? Because they already were started. Even companies that are going bust, doesn't mean that the product is bad, doesn't mean that it can't have a big success. Just mean that the financing is difficult, they maybe don't run a company very well. You know, many of these financing startup companies, they basically insist to bring in professional management. They actually kicked Steve Jobs out and brought in a professional manager that nearly ruined Apple. Did you ever saw a film about Jobs or read a book about him? What did you think of Jobs?
The movie?
Well, what do you think of the person from what you learned from the movie?
He's very insistent on how he wants to run Apple and what they do.
Obsessive.
Yeah, well, he insists on the way he wants to do things.
Yeah. Jobs first was a very creative guy. Second, great passion for detail. Okay, wanted things to be his way. Treated the people that worked with him pretty badly, but people followed him because he was the Pete Parker. And can you deny that Job was a genius? You know, he was kicked out of a company, he came back and made the company the most valued company in the world. And don't tell me serendipity. This is not. Jobs is a proven thing. And, you know, he got invested in Pixar, that did very well. He did a company called Next, and developing an operating system. And that operating system was better than anything in the market, but he didn't manage to make it stick. I'm not a big person, I don't focus on jobs and etc. But in Jobs' case, now Gates, what do you guys think of Gates? Does everyone know who Gates is? Gates haven't been running Microsoft for a decade. What do you think of him? He's a technological genius. He dropped out of Harvard, and with Steve Wozniak, he created a little compiler company that developed a basic compiler. And then he subleased DOS and released it and then bought it for IBM. And that made Microsoft grow. Then he copied basically. There is an interesting film called Pirates of Silicon Valley. You seen it?
Yeah.
It's a great film. And it's a story, it actually shows Jobs, shows the whole environment of that time. And when Gates goes with his job the first time, Jobs shows him the Lisa at that time and say, look what I'm doing here. I'm doing a Windows, I'm doing a system that is a touch and feel interface, full screen interface, as opposed to character-based interface. And then it came out, Lisa didn't do well, but then came out Macintosh. 6 months later, etc., Jobs comes out with Windows 1. And there is the scene, you remember the scene, I said, you betrayed me, you stole my idea. And Jobs said, I didn't steal your idea. Actually, this was developed by Palo Alto Research Center, Park, and you licensed it. And so I licensed it too. Okay? And it's very interesting the way, and actually I think Gates is less of a technological wizard the way the way Job was, but he's probably better, little bit better businessman. Okay, and you know he gave pretty much all his $70 billion to charity, and the Gates Foundation does fantastic things, and him and his wife Melinda spend a lot of their time basically on charity. Which is very, very interesting, the story, and I find it very interesting that Microsoft is adopting these kind of buy big strategy. Now, Microsoft has problems. They have a aging product line. Windows is old and Office is old. They have a search engine that is secondary, if not tertiary. And control of that search engine is very important. And you might have heard Microsoft troubles with European Union. And Microsoft had this interface that was basically a line interface in DOS. And then they got Office going and etc. But what happened is the web came in, World Wide Web. And they were very afraid that the interface of Windows would be replaced by a web interface. So they basically, at that time, the top browser was not the Microsoft browser.
Navigator, I think. Navigator.
Oh, there were a series.
Yeah.
There are a series.
Netscape.
Navigator.
Netscape was before Netscape. There were others, etc., etc. But what he did, he basically forced.
Huh? I mean, didn't Microsoft got in trouble?
They got in big trouble.
Yeah.
They forced that their own browser become the browser in DOS, a browser in Windows. And they wouldn't let other browsers come in. And with that, they basically killed Netscape. And they got big punishment by the European Union and etc., but worked for them because they kept the leadership on. And now what they're afraid is that the thing people are going to access first is search. And they were afraid that Google would basically decide to put their own operating system behind it. Did they?
Yes.
They did. Was it called?
Chrome.
Chrome. And is Chrome good?
Oh, yeah.
Is it better than Windows?
I think use
And how come they didn't take over the markets?
a lot of products on the market are not compatible with Chrome yet.
Same thing that happened with what happened in search, happened with web. Many products come in, the product margin becomes very small, might not be worthwhile being in that business, and is diversified enough that IBM is not afraid, in this case Microsoft is not afraid to lose the technological leadership because it's not going to replace what they have. The other thing is they have a huge user base of Windows, and they can make life pretty miserable to adopt another browser. Which browsers do you use? What do you use, Antonio?
I use sometimes Firefox.
And with it, Internet Explorer. What do you use?
I prefer Chrome, but occasionally Microsoft cons me into using Edge.
So this is the trend that I see using 3-4 different browsers. And why do you use different browsers? Huh?
They have different functions.
They have different functions, they do different things. Okay, for example, I use the Google Calendar. So have the Google browser makes compatibility much easier. Okay, and what's the problem with using different browsers?
Talk to each other.
Huh?
They don't talk to each other very well.
Yeah, and applications, certain applications work with one thing, don't work very well with the other. Like for example, I was using the Rutgers ERP system yesterday. And the Rutgers ERP system basically allows you to give allow for guests sign-ups to Rutgers. And I have a senior researcher working in my research center I want to give. And I go in there and the thing doesn't work. Finally, they send me that my browser doesn't work. Okay, use a different browser. So I use a different browser, worked fine. And you all have this experience. But let's go back to Microsoft for a second. Actually, Microsoft is trying to become more of a Google. They are going to try to collect huge amounts of information about you. I bet you that they collect a lot of information about you out of Office, out of the operating system. Okay, so let's stop here, and I know this is redundant to many of you, but many of you this will be helpful. So I'm going to do a very fast go over basic technology, just for us to make sure we have the same. All my slides are always available for you. If you don't find it, just ask Abdul Rahman or ask me. And this is out of our sequence because I talked to a couple of you and I got a little bit worried that we're not speaking the same thing. So this is your house, okay? And your house used to have a device, which was a telephone. How many of you have fixed lines still at home? Half, if not that many. How many of you don't have a cell phone? How many of you don't have a smartphone? You have an old-fashioned phone.
Yeah.
Can you imagine how technology changed? Meaning, I'm going to talk a little bit more about it. Now, technology of telephone is what we call POTS line. POTS standing for plain old telephone system. POTS. This terminology we use at Bell Labs, at AT&T. Okay, and people still use it. And what is that physically? That physically is twisted pairs of copper. So you have in the wall a wire, and the wire has copper like this. And two wires or maybe a third ground wire. Okay? And those little ground wires go to the street, and they go into pairs, and pairs go into 20s, and 20s go into 28s. So that is very fat telephone cables that you can see in the street sometimes. They pull in the lines and et cetera, et cetera. And they basically transmit to a thing called analogic. What does that mean? The waves are waves, as opposed to what we call digital, which is yes, no, yes, no, yes, no. And so that's the technology of the telephone line. Most houses in the United States, like 90% of the houses in the United States used to have physical lines. And 20 years ago at AT&T, we pretty much predicted that this would not be a very profitable business in the future, and we are totally right. Now, on top of that, we developed a broadband technology, which used to be called DSL. Now there are a lot of variations on that. So that's broadband on top of twisted pairs. And then progressively, people started putting cable in their houses. And cable is not transmitted by twisted pairs. Cable in general is transmitted by coaxial. And what is coaxial? Is a wire with a covering with some metal outside and one little wire in the middle. So instead of being two twisted pairs, is one white thing. And you know exactly how it looks because it looks similar to what a cable TV wire looks like. Okay, so it's kind of a round thing with a little wire in the middle, and you know when you plugging your cable TV, you don't want to bend that little thing in the middle or it's not going to work. Everyone had the problem of that thing bending, and you didn't know why your TV was not working. And then you call support, and the first thing they ask you is, did you bend it? Did you just connect it? Okay, now, what that allowed is What that allows is a little bit better bandwidth. What does bandwidth mean?
Isn't it kind of like a capacity?
Yeah, it's like if you have a pipe, how much water goes through it. So bandwidth is how much information can go to a particular wire. And what has been happening over the years is that they changed media, so they went from twisted pair to coax, now having both, and now fiber, who allows a lot of bandwidth. They probably kept the old ones. But then the other interesting thing is that technology got better, and they managed to put more and more information to the same pipe. And this continues growing, and as physical media is changing a little bit, their ability to concentrate data over a pipe became better and better and better. And of course, this is all what you're interested in, is bandwidth.
Yes.
You don't want to sit around and wait until your computer does something. And very often the reason your computer is being very slow is not because the computer is slow, it's because your information that you're getting is not very fast. And of course, in many countries of the world, you can buy variable bandwidth. So you can pay a little bit and get a narrow bandwidth, pay a little bit more, get a wider bandwidth. And even in the US, you can do that. There is this commercial lines and there is a private line. And even some vendors will limit your bandwidth by saying you can only download so many bits of information when you are streaming, and then you have to pay extra. Well, so you very rapidly understand what bandwidth is. It's how much information you transmit. Okay? And so they had this kind of two methods of transmitting, and they developed this technology which they call fiber technology. And what is fiber? Fiber is basically a wire made of glass. Of glass. And you grow fiber. What does it mean? You create a glass string. And in the beginning, they were very, very bad at doing it. And so they threw out 80% of the production. But now they got much better at growing glass string. And basically you have two of them. One where the signal is going, the other one the signal is coming. And in the end of them, there is a laser going beep, 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 beep. And as you realize, it's not a wave, it's a yes and no. And yes and no is digital as opposed to analog. Now, if you use a traditional telephone receiver, the receiver is analog. The wires in your house typically are analog because they're copper. And then the moment it hits the street, it hits fiber, and there is a box that converts analog to fiber, gets to the other side, gets converted from, converts analog to digital, goes over fiber. And many neighborhoods still have copper in the loop. What does it mean? From the telephone central to your house, they still have copper. But when it gets to the long distance transmission, it's all fiber because it carries much more capacity, and they put they multiplex it into many telephone calls in one fiber. Now this is totally different with wireless. But the next stage became satellite. And I'm sure you heard about some satellite transmission vendors, correct? If you want to go to satellite, what is your vendor? Huh? Dish Network, of course. Okay, and actually Dish Network, when satellite started, download came this way, upload went to the traditional telephone line. Now they can do both ways, and et cetera, et cetera. Now, what's the problem with Dish Network?
It's weather.
Yeah, the weather interferes a little. Okay, but there are reasons where you would use Dish. Yeah.
It depends on where you are. It has to face the south or something like that to a certain degree, like where you.
So you depend on the setup. You depend where the dish is turned and etc. What is the great advantage of Dish?
doesn't have wires.
That's good, not having wires, but the great advantage is if you're in a rural area where you don't have wiring, you still might get this up. Okay, and of course people are now going to join. And now what actually came in, the most common, this is actually technology that hasn't survived. And it was a wireless thing directed, and it would bypass the loop. Let me just kind of do a drawing here what the loop is. AT&T, as a good example, has about 140 boxes that are the switching equipment. And then from the switches it goes local, and they have that thing called the loop. And when AT&T divested from the operating companies, the loop became Verizon. The switches still was a national system, but actually Verizon owned the switches. That's why we did a continuous auditing project and et cetera, et cetera. Okay, but if you think this is pretty clumsy, you have to bring wire to everyone's house. What does that mean? You have to bring wire, you make holes on the streets. Then like one of my telephones in New York is not working. And they say that they have problems with some cable and they have to replace the cable. I'll get my telephone back in a few months. Okay, if this was 10 years ago, I would go ballistic. But now, I don't even use it very much. Don't even know why I pay for it. Okay, that's why half of you don't have telephone, don't have fixed lines. And of course, the price of cell phone plummeted. And the fixed lines remain basically the same. AT&T makes more money with cell phones, with cellular product than business fixed line and private fixed line. And it was a time that was cellular, of course, didn't even exist. And so the other method is cellular connectivity, and the usages of cellular connectivity are totally expanded. So just coming back to some terminology, we talked about POTS lines, and we talked about coaxial, and eventually we talked about media being fiber. And remember what I said is digital, analog is waves, digital is just yeses and nos. And that's why lasers are in the end of fiber. Why are lasers in the end of fiber? Because they all, yes is the pulse, no is no pulse, and there is a clock that calculates where a pulse should come and out. Very simple to understand basics. Complicated to do too much with it. And these were the transmission medium. Copper, optical fiber, and coaxial. I forgot to tell you one thing. Fiber became much better in transmission. They embedded rare metals. They did all kind of tricks to make that glass better transmitter of information. And so fiber, generations of fiber has tremendous differences in their ability to carry information. Now, the other comment here is the backbone. And the backbone always existed, and there were these T1 lines, 3 lines, and etc. But now the internet has a backbone. And basically there is this big fat cable that carries a lot of information for the internet. Every country has a backbone, and actually every country has several backbones. And then out of the backbones, little rivers come out, some little smaller backbones, and then out of the smaller backbones come up distribution centers, and out of the distribution centers comes your signal. So it's a distributed thing. However, if there is a major accident on a backbone, you see it. Your transmission becomes bad and etc.
So if you're getting, let's say, data from satellite, do you go through backbone?
You can avoid it. Sometimes it's direct, sometimes there is a return. Okay, so we did up to
Yes,
to here. And I'm not going to cover this because this technology already has changed. Then there is the idea of packet switching versus line switching. So, when telephones were invented, supposedly Alexander Graham Bell, the technology was such that I wanted to talk with a bully. I would pick up the receiver in my house, and someone in the other line picked up, that was the operator. And I said, I want to talk to a bully. And she would pick up a wire, connect to my phone, pick up another wire, connect to a bully, and then press a button and would ring. Okay, it was all manual. Progressively, they replaced the operator with electromechanical switches that moved arms, and at the end they are all kind of digital and transistorized and circuitized and etc. etc. Okay. Now, when I talk to bully, I said something, the signal was transformed into an analog signal, and when it got to the end, it was transformed into voice. That's the way it worked. Now, in recent years, not so recent, they started developing a thing called packet switching technology. And the packet switching technology basically transformed this into digital, and then transformed the utterances, when I said, into packets. And the packet was transmitted to the central, and the central transmitted to wherever you are talking. And the advantage of packets is that when I was talking to a bully, at least in principle, the line only belonged to me. But when I'm using packet switching, I am here, goes the switch, and then I can put many, many packets in the same line. So it concentrates the line. And traditional telephony has packet switching, but the big usage of packet switching these days is the internet. And also with traditional technology. So packet switching is, you transform this into digital, and into digital you compress them into packets. And just to advance things a little bit, an internet packet has the front end of the packet, which has your IP address, and I'll come back to IP addresses, the address IP address, and a little bit of information in the packet header, and then the content here. And this can be encrypted, so it can be protected. But this cannot be encrypted, because if you encrypt the address you're going to go, the switch will not know where to send it. So you can protect yourself with encryption only the body of packets, except there are some mechanisms whereby you can mislead the switch, give it a different address, and then there'll be another switch that tells it the right thing. Okay? So, and you see, most of the things I'm talking about, something we're going to use a little bit. Now, typically, telephone switches are called switches. Typically, switches that pass packets around are called routers. And for a while, in the series of Microsoft, IBM, Cisco was the real hot telephone company, the real hot technology company. Why? Because Cisco made routers and everyone was buying routers. But now there are hundreds of companies that do routers. I bet you that 90% of you have a router at home, or 80. How many of you have a router at home? Okay. Do you guys in the back there have a router, or we are too busy doing something else? Do you guys have a router at home? So what is a router? It's something that you connect onto the internet and distribute signal in your house, either wirelessly or 2 plugs. Most routers will have like 4 holes in the back. 3 of them will be line. I think the 4th hole is for the signal to come in. And then you can have 3, 4 other wireless stations in your house. Okay, and they cost $30 or $50. Or some of you don't have a router, you just have a switch at home, basically connected to the internet, and inside it has already a wireless router for you. Okay, Professor Issa here doesn't like telephone company provided routers because he said they know your IP address, they can discover a lot of things about you. So he puts his own in there, like I do, and protects it. I do it because I want more powerful and more transmission power. Okay, now little story again. Okay, when I was doing my PhD, I'm not going to tell you what year, but it was a long time ago. Guy at UCLA called Leonard Kleinitz developed this idea of making 2 computers being able to transmit information. Kleinrock, sorry, it's Leonard Kleinrock, and he made this thing that made 2 computers talk to each other. So this whole idea of teleprocessing, telecommunication has been around for a while. But the technology perfected, and before, the first thing you could do is just kind of with your computer access the other computer. And then progressive, you could transmit information between the 2 of them. And then they started doing these very primitive networks. And the US government financed a thing called ARPANET, Advanced Research Project Agency Network. And so prime universities had access to this networking. And with the technology that started by Kleinrock, and other universities didn't have it. So they got jealous, and they created a thing called BitNet. Kind of similar technology. One thing for you to know, we're going to talk about this repetitively, is computer scientists are very willing to share code. So there is thousands and thousands of servers that only serve to distribute code, to distribute programs for free. I give you mine, you give me yours, and et cetera, et cetera, et cetera. And a lot of the great advancements in technology came for the ability and the desire of companies to share it. Don't think that Microsoft and Google are the example of this. The example of this is computer scientists, professors, programmers that have all these huge libraries of code. So you don't have to rewrite code, you just pick up a piece of code and use it. And so, and then some commercial vendors like Wang used to sell networking things. And then there was a study by the government. And they, remember I was talking about the AT&T network and the switches? They discovered that if atomic bomb was placed carefully in the boundaries of Washington, D.C., the entire network, telephone network of the monopoly carrier AT&T would go down. And the US would have no telecommunication. And just imagine what the Russians would do to us in that evening. So they started financing this idea of networking. They wanted something that could not be interrupted. And finally, they came up with this idea that if they interlink different networks, they would have a better fault reliability. And so they created this internet protocol. And the technical name of the technology, or you don't have to put the dot here. And TCP stands for Transfer Control Protocol. And that's the computer code, that's the protocol of dealing with packets. So when you go and visit a website, this is a misnomer. You don't go and visit a website. You ask the website to send you the website's pages. Okay? So when you request a page from a website, the website sends you it in packets. When all the packets arrive, TCP puts them together into something that you can read. However, if the thing that you're requesting is music, or sound, or movies, it doesn't wait until you put everything together. It works reasonably well if it only gets some of the packets, not all of them. Okay? So if you start noticing that your signal starts going bad, you know what happened. What's happening?
It's buffering.
Yeah, it's buffering. But why? Is that packets are not arriving. You're only getting part of the packets. And that's due to either the network being overloaded or the server in the other side being slow. Or maybe the other reasons, but that's the main reason. So they created this thing, TCP, and then they needed this protocol to identify each computer that was on the network. So they created this, let's say, 128, 62, 1, 0. And these numbers are all numbers from 0 to 255, which stands to 2 to the 8, binary. And so there are 4 of them. And they each one determine a particular user on the internet. So Cecilia is connected on the internet at this moment. She has an IP number. Now, in old days, most IP numbers were fixed. So you go in the wall, and that particular hole there with the plug had a number. But these days, most people use dynamic IP allocation. Cecilia opens her computer, tries to go on wireless. Rutgers lends her an IP number for that particular usage. If her computer crashes and she disconnects, she probably will get a different IP number. So IP numbers tend to vary. But Rutgers get given a bunch of IP numbers. Essex Community College get their IP numbers, et cetera, et cetera, et cetera. So, and typically the country distributes their IP numbers. So you get a big bunch of them and you allocate them. Some are fixed, some are variable, and these days most of them tend to be variable. Your cell phone gets an IP number when you connect on the internet. Everything needs an IP number. And if you go 2 to the 8, multiply by 2 to the 8, multiply by 2 to the 8, multiply by 2 to the 8, you have 2 to the 32. It's a very big number. However, we are running out of them. So they're now coming with the standard. They are progressing towards the IP6, which will add 2 more of these. So this number can go from 0 to 255. And think about 2 more, it's a horrendously large number. And so that's what IP number is. It's just a denomination of the location of your computer. How do you connect to your computer? Okay? And so everyone has a number. Now you're going to ask me, how do I identify the IP number of www Rutgers EDU or Andromeda Rutgers EDU or whatever you're using? Okay, you need to have that address, which is a character-based address, converted to an IP number. And so they have these things called domain name servers. And a domain name server is basically a big list of names and numbers. Okay, but these are for the fixed IPs. Yes?
Like would Rutgers Wireless have a set number of IP addresses? Like do they have a certain...
Oh yeah, they get
number,
allocated a large number of IP addresses, yes. And they try to develop the internet in a way that is ownerless. It's kind of an international consortium. And that was reasonably easy, but now there is a lot of commercial interest kind of affecting it. And we'll talk a little bit about that over the, so we covered over the course. So we covered these 4 things here. And this organization called Internet controls the domain names. And domain names is that Rutgers edu. And typically you have XXX Rutgers edu. And so typically this is the name of the computer, and this is the domain name, or you can call it domain, subdomain name, domain name. And you know that in the US there is edu, there is .com, there is .net, etc., etc. And they were kind of designed to specify what kind of organization they are. But most other countries, all other countries, will actually have their country initials in there. So let's say would be FGD dot edu dot BR for Brazil. Okay, and some of them has the edu, com, etc., etc. Others don't have that. Only have the domain name. Okay, and the generic idea was there would be a big domain name server for edu, a big domain name server for com, and etc., etc. But they became too big, so now they distributed this to a certain degree. And this is what I was talking. There is a backbone of the internet, and this is only symbolic, it's not really the reality. And then you have sub branches, and then you have your internet service provider. Who is your internet service provider at Rutgers? Rutgers. Correct?
Really?
You don't pay for anyone else, correct? And who is your internet provider at home? Verizon,
Optimum.
cable network, Time Warner, etc., etc., etc. And you pay these guys to give you internet access. And there are really 2 components of this thing. One component is the person that provides you internet access. The other component is the telephone company that provides the wire. And in the old days, for example, in Brazil, you would have to pay the 2 of them separately. But most of today, typically the telephone companies took over those 2 roles, and you only pay 1 internet access charge to get internet. So, for example, these days you don't pay just to get internet, you pay for getting broadband. And you pay $40 a month or $35 a month to get internet, and every few years you get bigger and bigger bandwidths for getting internet. And I already covered this. Each node has an identifier. What is the identifier? The IP number. And there are really kind of 2 types of things. One type of thing that distributes content, the other type of thing that is your personal IP access. Okay, and although there is no reason for that, meaning if you go to Time Warner, they provide you internet access, you could have a computer at home that has a lot of content, and you are acting as your content distributor. But what actually happens is that Time Warner doesn't like that, because at that moment you are using a lot of bandwidth and paying very little. So what they typically do is they have a commercial IP numbers that are permanent, and then they have yours. And yours changes some do it every week, something every couple of weeks. So the one IP number that you have at home will tend to change, because they don't want you to be a vendor on it. For being a vendor on it, you need to pay extra. Now there are websites that will keep an eye on your IP number and will be an intermediary in this, but usually you have to pay for that too. So that's okay. Oh, and just one more comment here is you can have many different equipment on the internet. Doesn't all have to be the same equipment, same operating system, and etc. Now, one of the things that happened, the internet was designed to link, let's say, a WAN network and, let's say, BitNet network and other networks. And basically, the TCP/IP protocol was designed to be placed on the computer of the entrance of this network and intercommunicate them. And what actually happened that this protocol, the TCP protocol, TCP/IP protocol, was so good that people say, why am I going to have the WAN network and then move it to TCP/IP? So people started putting TCP/IP in the computers of the network and addressing it. And when you go home and look at your router is going to have a number inside it. And this number will serve all your locations, your computer, your Internet of Things, whatever you have in there. And it will be smart enough to, when it gets a message, your router, it knows it goes to your printer, it goes to your computer, it goes wherever it goes. Okay? So you have an internal IP address and then an external IP address. You don't have to know this. Yes?
Just probably a really stupid question. Is somebody owns the backbone, or like how does backbone?
Okay,
yeah.
it's not a stupid question, and you have to ask questions because this is knowledge that goes in building blocks. If you don't understand the lower one, you won't understand the higher one. So ask it before you start. I don't understand anything that happened. So tell me about your question again.
So is there an owner of backbone?
Okay, I just wanted everyone to hear it. Is there an owner of the internet? Actually, the way it worked is that the US government used to finance the backbone. So in reality, the US government didn't go and build backbones. They went and hired AT&T and used those fat cables I was talking as the backbone. And then they went to Verizon and bought some there, depending where you're going to go. And so they financed it until, like, I think was 84. And what happened then, the US government, which is criticized a lot, but something they do right, okay, what they basically said is we are not going to finance any more backbones. And said for these guys here to pay for the cost of the backbone. And these guys charge you for the cost of the network. And what they did, they started dedicating their money to improve the speed of the signal, I mean the bandwidth of the signal within the networks. And so look at the government, it was pretty smart. Telephony was developed, Graham Bell. And Graham Bell basically started trying to sell it. And I'm going to show you something very interesting very soon about that. And basically some small vendors, like with initiative, started using that technology in connecting houses. And they would put wire in the ground or to the thing and develop. But there is this axiom that the value of a network is proportional to the square of its locations. So if you have one element of communication is useless, correct? Because it only talks to you. If you have two, already they can talk to each other, it's worth 4. If you have 10, it's worth 100. Because who wants to talk with a telephone company that you only can talk to 5 people? It's pretty obvious, isn't it? But the economic consequences of these are interesting. Because then there were small networks and there were guys that were richer and have connected to more people, put wire in the ground. And they spoke in different protocols, and they would not merge. Why they would not merge? Because they knew the smaller vendors had much less value to offer than the bigger ones. So the bigger ones would just wait until the customers of the smaller one would migrate to the bigger one. Correct? Do you understand the story? So the value comes in the bigger network. So what the US decided is to intervene and created this idea of a natural monopoly. And what was the natural monopoly is AT&T is the monopolist, holds it, but AT&T has to develop the standards, and everyone has to obey those standards. Those standards are free for the world. Okay, and so that's why it came area code, 3 digits, 7 digits, the phone number. And there were hundreds of ICOs, independent telephone companies. But they could interconnect in because there was one standard. And each state had its telephone regulatory commission that set standards. And the rule there was that the carrier only can make, I think it was 10% profit. So on all the money they collected, 10% went to the carrier, the rest was used for costs and etc. And so Bell Labs, where I was paid by the customer. So the patents of Bell Labs were public patents. And this did very good to the United States because United States telecommunication network was the best in the world by far. In '84, AT&T was pressured to divest, meaning they said it can't be a national monopoly anymore, there's no need, and etc. And both AT&T and IBM were sued for the same reason. IBM hired Nicholas Katzenbach, ex-attorney general, and fought it, and managed not to divest itself of components. They were still the monopolistic dominant company. AT&T just complied. And so AT&T split out 7 operating companies, and AT&T remained in the middle. Okay, and since then, the US telephony deteriorated. And so many countries became better in telephony than the US until another major technological revolution came in, which was wireless. And that's a whole different ball game. And the whole thing is kind of rebalancing on itself. Natural monopoly doesn't mean too much anymore. And the other thing is, because remember, it's kind of bricks and mortars, really. Meaning for you to have a telephone network of traditional mode, you have to dig in the ground. And the rights of way are expensive. You invest a huge amount of money. And so the US tried to force the people that had the wires in the ground to provide access to everyone. And that's a whole different story. But now, wireless can compete. You don't need to dig things in the ground. And there is this kind of equal access philosophy. And so you can have 2, 3, 4. I am just thinking of changing to T-Mobile from AT&T after 20 years, 30 years of AT&T because they have a better offering. And that's kind of good for the country and et cetera, et cetera. And this is a technological innovation that changed it. The meaning was telephonic service was expensive. And cell phones in the beginning were very, very expensive. Okay, so this is kind of, did I answer your question approximately? Yeah. And this continuation, this whole thing was to tell you a little bit about the government does some right things. Creating a natural monopoly at that time was the right thing to do. Financing ARPANET was the right thing to do. Part of the internet was later financed by DARPANET, by DARPA. And DARPA is Defense Advanced Research Project Agency. So, by the military. And why would the military be so interested on networking?
You can now transfer communications, espionage, things all over the world now. And
That's right. They are very. They certainly didn't want the Russians to do that before, correct? Or the Chinese or whatever. Okay, it was really the Russians at that time. Okay, and with that financing, and then they financed the backbone, and then they stop financing the backbone. They finance concentration techniques, and goes on and on and on. Okay, just to kind of pull the story together, Antonia is the client. she's sitting here. Okay? She wants to get a web page, like the new www.newyorktimes.com. Okay? So she wants to send a packet to the New York Times and say, please give me access to your homepage. But she doesn't know the IP number of it. I'm just using nothing, and here's myyahoo.com. Okay? She doesn't know the IP number, so what she does? She goes to a domain name server and when you specify your access to the internet, you actually tell the network where your domain server. Here is Rutgers. And each one of the main Rutgers computers are also a domain name server, so you don't have to go very far. Okay? And what that does is a list of these domain names have this number. And if he doesn't know it here, he knows where to go to find it. So when you're asking for a page, it takes a little bit longer the first time. Why? Because you went and asked the domain server the number, and instead of being where you are, let's say that you were at myyahoo.com, and then mine would probably be a computer. You would say 128.75.2.17. And so from here on, and if you look carefully at your URL in your browser, now and then one of these things pops up. Have you ever noticed that? And this is basically a full replacement of my computer now is this number. Okay, and then you have the rest of the name, and the rest of the name is a directory like you have in your PCs. So typically when you go into the web, the first page you see, and if you don't specify anything, is a thing called index. And index is actually a home page. It's not called home page. But you might already have specified other things. And so this might be replaced, but this address remains the same. But you didn't look this up in the domain server, you just looked the number of this guy up on the domain server. So here it is. It's found on, the domain number is found, and they return your IP number. And then what you do is you request a page. You create a packet that has address packet, local packet, maybe some other information, and then the address you want to go. And then the other side, and what you are actually doing is, what is my little drawing that I started? And then this goes to the internet, to a series of routers, and finally goes to Yahoo. Okay. But that page in Yahoo that you're asking is usually many, many files. Because what does the web do? The web allows you to link text to it, pictures, and voice, and video streaming, whatever you're doing. So you typically break down each file, like a voice file or a text file, into packets. And then those guys are sent back to your computer, and TCP/IP puts it together. So it's a complicated thing. A simple click generates a complicated thing for you. And as I said before, if it's video or audio, it doesn't wait until it gets every packet to reassemble it. If it's typically text or email, it waits for every packet. And it finishes up bringing all the packets together. If somewhere in the network here a packet disappears, it's asked for again. So The files are broken into packets. Each packet is thrown back to the net towards your IP number. When all packets are received for a file, this file is reassembled. Several reassembled files from the web page is requested. So look at the elements here. You have the packets. The packets are pulled together into a file. Several files compose a page. And the page could be a home page, could be other pages. So that's the story. And it works very, very well. And this is very important for anything you do in marketing on the internet. Okay, what is a hit? A hit is when you receive an entire file. Okay, an entire file could be several packets. Okay, and one page has several files. So, and why are these measurements important? Because you want to know how much an internet site is being used. And then the next thing is a visit. When Matt goes onto the internet and he's fiddling around, let's say Macy's. When he started, the first visit to Macy's is his first page visit, and then he goes several. So he's a visitor. And then when he goes back, he's a repeat visitor. However, if John goes in there, he is a different visitor. And it's very important to measure in the internet how many visitors you have, how many repeat visitors were. And then there is this whole story about click tracing. And what does that mean? You want to understand what Matt was doing there. Was trying to buy something, was comparing, was just seeing the products, was using any features that you have. That kind of a whole different set of analysis that you're going to do. And then there is this issue of identifying visitors. In old days, you had a fixed IP number. It was very easy to identify you. Although you didn't know exactly where people were, you know this is always from such and such IP. Today, each one of you gets many IP numbers all the time. So they want to identify you. So most websites, many websites, develop this idea of asking for a password and identification name. And why do they do that? Much less to keep confidentiality than to identify you, because that's for marketing purposes. But remembering thousands and thousands of names and passwords is rough on you. You already have to remember them. So what do they? You have this thing called cookies. And what is a cookie? Is basically a file that your browser keeps with your name and your password, your name and your password. And they can do other things in there. And for a long time, there was a lot of problem with confidentiality of cookies, and people would kind of steal the cookies and know a lot about you. And you still have a big problem in cyber security with cookies. Because what happens? People leave cookies to collect your information. They're called tracker cookies. And now and then they send it to the website that collected it. So when you run your virus detector, the virus detector calls your attention. There was this tracker cookie here. Have you ever seen those messages?
Yeah.
And typically what does it do? It disables it, deletes it, or just freezes it away from it because it doesn't want it. And you'll notice that every time you use your deviruser, you find tracker cookies because they're always loading them onto you. Now, this causes some interesting technical questions, which is, who knows what about you? And this guy here knows everything about where do you visit. Because they keep a log of IP addresses received and sent. However, that doesn't tell you too much, doesn't tell you the content of, because your message could be encrypted. And very often, by default, is encrypted. So they know something about, you know what website, if you visit a lot of naughty sites, they know it. But you have an advantage too. The advantage is that this is a very long list. And over time, this is very rapidly becomes very difficult to manage. So they don't retain it for a very long time, and etc. The idea that you can go to internet service provider and find out every visit that the terrorist did in the last 20 years or last 10 years is crazy. This is not kept at all. Okay, now the guy in this site first doesn't know who you are. If you have a cookie and you identify yourself, they know who you are, and you know everything they know, everything you did in their website. And you can interpret it a little bit. And the other thing is, they know who you are is a little bit questionable, because you might decide that your name is Mickey Mouse and not give them that information, and the IP will be varying, so they can't exactly identify. Now, there are some companies that actually bring together many websites. One of them is called DoubleClick. And basically it's a service that you give your logs to DoubleClick. Other companies give their logs to DoubleClick. And they can do more interpreting who you are and what you're doing. And there was, when this started happening, there was a major set of reactions by the public, the people that understand the internet, say this invasion of privacy and etc. And so they put some ombudsman in their boards, they tried to clean up the act a little bit. But I remember what I said about privacy. Okay. Now this was the old corporate internet access. These things I call PPP slip are the dynamic IP allocation. And there was a firewall in your network. What is a firewall?
It blocks incoming traffic you do not want. It protects what you have.
Yeah. A firewall is exactly some form of protection that you have. It used to be on your corporate network. Now all of you have firewalls in your routers, and you can re-specify it. And it goes, the 4 Ps goes from promiscuous firewall that allows everything to paranoid firewall that blocks most things. And do you want a paranoid firewall? It will make your life pretty miserable.
Yeah.
You want a little bit of a compromise there, because a lot of things you won't be able to do. Okay, firewalls are a necessity, but they take some technical ability to configure them. So when you buy things that are firewalls, typically they come pre-configured to you. And companies, of course, have much more concern about firewalls. Okay, domain name server. Okay, you all know what HTTP is, correct? You find it in front of every website that you define. The name, and that's just the name of the protocol. And SSL is an encrypting protocol. Okay, and digital certificate is something that tells you that that particular website is legitimate. Now, all of you had this experience of surfing the web, and then something pops up in your computer and say, we don't know what this website is, they don't have a digital certificate.
Yeah.
And what do you do in that case?
Continue.
What do you do, Andrew?
Just push continue anyways.
That's exactly. Most people ignore this. Leave me in peace. You have to do 3 clicks to get rid of that thing. Okay? But if you are doing kind of you go in the internet and you find something that you want to dig out, and you're already a little bit worried about it, and then you get one of these, then you stop. And of course, you have a lot of concern of going the internet and picking up things that are bad, that will block your computer, that will leave cookies behind, very extreme type of things. And so probably the best rule to start thinking about internet security is never click up on a link or on an attachment that you get that you don't know where it's coming from. And if your good buddy sends you something that you're not expecting, send him an email and ask him, did you send me this? And now and then you're going to have this very unpleasant experience that he didn't send it, or she didn't send it. So it's first good rule of internet security is never click on something that you don't know. The other thing, anyone that sends you a message saying click on this to look at your account and etc., don't. If you get very worried, what do? You go in your browser and type in the address of that place, not the address you got there. Like you get a message from AT&T, say we have problems with your account, click here and we can save, and give me your password too. Okay? And that's what you're going to do. You're going to go www.atnt.com, get AT&T and go your username, your password, and then see if there is a message. And you're going to find it regularly that's not. Spoofing is a very, very common thing. And don't trust the name that you have there. Oh, this is from AT&T, it's good. Because there'll be some control characters that you can't see and are in there. Okay, or it's going to say something like supervision AT&T. Okay, and someone got that domain name. I actually don't understand how some of these domain names are allocated with obvious spoofing addresses. And I think there should be a little bit more of supervision of what happens there. The other thing I think is there is not enough policing and legal enforcement. You see, going out and shooting someone in the street or tree, stealing their wallet, or going to a bank with a gun is a very primitive way to steal some money. Okay, and you see, people talk about crime is going less and etc. It's true. That type of crime is going less because there are much better ways to steal money. It's very, can you imagine exposing your body, going to a bank with a gun? You might get shot. Very unpleasant. Correct? And so obviously there is a large expansion of cyber crime type of things. When internet started, a lot of the hacking stuff was for sport. Okay, just to show that you're smarter than the next guy, show that you could do something, you had fun with it. Typically wasn't destructive and etc. And there is a lot of that still. But there is a whole sub-field now, which is professional hacking, which is making money out of people's accounts, making money out of people's information, making money about entering in someone's website, and et cetera, et cetera, et cetera. And so with this kind of sophistication, you have to be much more careful. And I think we're kind of losing a little bit that battle. Switching okay. One more thing I wanted to demystify for you. And can you please tell me what the cloud is and what is cloud computing? You notice I even do the internet as a living cloud. But that's the representation people use. What is cloud computing?
Like if I have a cell phone or a computer, as opposed to storing my data on my hard drive, I can send it to cloud, which in my mind is kind of like this amorphous.
And so when you're flying with an airplane, you hit it?
No, it's actually on the, well, it's someone else's database. Like someone else has a bunch of servers and things like that, and I can access it from like my phone or my computer. I don't know, it's limited to a country I'm in, but I'm assuming it's all over the world, and I now have access to my data, not the hard drive.
Okay, so we're not too far there. What that cloud means doesn't really mean a cloud. What it means is that some people went somewhere and built huge warehouses with thousands and thousands of computers linked together, put an operating system on top of it. And instead of you storing things in your cell phone or in your computer, you use them to store some of your stuff. And they organize so well that they are distributed all over the world. And if one has a problem, other ones take it over. And so the idea is basically redundant, fail-proof, distributed computing. What is the big problem of you using the cloud?
Or like sometimes stuff is on there that you didn't know was gonna be on there.
Okay, so that's kind of a content problem, but that's not the biggest, I would say.
People getting access to it.
Also a big problem, but not the main problem. The main problem is to access the cloud, what do you need?
Internet?
You need connectivity, you need the internet. And still, if you store a lot on the internet, what happens? The bandwidth is very narrow and takes a long time to pick it up. I bought a terabyte on Google Cloud, Google Storage, and I never managed to fill it. I keep adding my 100 gigabytes of music, and it just takes forever. So I gave up on it. Okay, I now moved to Dropbox Cloud, and they are faster. It's easier to organize. I bet you most of you use Dropbox here. Who doesn't use Dropbox here? So what is the concept of Dropbox?
I think you can get files to other people, like put stuff in there.
Okay, the main concept of Dropbox is this is a computer storage that is common to many devices that you have. Okay, so what does it mean? I have a laptop, I have a cell phone, I have other laptop at home, I have about 6, 7 computing devices. I have Dropbox. And so anytime I connect the computer to the internet, it goes to Dropbox and see what I have here, is it similar to what's there? If it's not, it updates it. And so all my computers are synced. In old days, what did I have to do? Is manually sync them, which was a pain. And particularly if you change things, yes. So
How is that different than a cloud though, if you still need
it is a cloud utilization. So there is no great difference except it's a commercial cloud with certain characteristics. Okay, but it is a cloud application. And what everyone does is these games to get more Dropbox space. For example, my music and my pictures definitely didn't fit in my Dropbox. And actually what they do, they would make my Dropbox not update because I filled up my Dropbox and then I put something new in there, it said, oh, I can't do it. So I went out and closed my Google account and opened the terabyte Dropbox. Except my laptop is only 250, doesn't go to terabyte. So I have to tell my other devices, or this device, not to update music, not to update pictures, just keep the things I'm losing. But it's getting to the stage that is nearly interchangeable, getting bigger computers and etc. Dropbox is a great device. Now, what you described is actually expansion on Dropbox. I can now say my devices do my Dropbox, but I will allow Andrew to use one of those directories or one of those subdirectories. So when I do this with all my PhD students that are doing projects with me, we have common Dropboxes. So anytime you update the paper you're working the paper with Denise and Professor Kogan, that we have probably 50 versions of the paper. Okay, every time Denise updates it, she puts in there. Then I edit it, I put it in there. Okay, it's very, very practical, very, very nice. But you know, Dropbox is a really very good device. It makes your life much easier. Okay, so that's kind of a small cloud application. And I have no idea what the infrastructure is. I don't know if they have one big computer center. Bad idea, because if that one crashes, I'm done. Or more likely, they use Amazon Web Services. And what is Amazon Web Services? A whole network of websites, or of cloud sites, and they have some mechanism to keep each other updated. So if this one goes down, this one happens. And you know what they are doing with these large computer centers? They are the size of 5 football fields or something ridiculous like that, with 100,000 computers in it. But don't think of the computers as little boxes like your computer is. What these are just basically motherboards with the capabilities. And thousands of these things. In old days, people built very large computers. IBM still does that. But most people today want a large computer, assemble a lot of small computers. It's cheaper. You produce it in mass production, so the cost of a board, instead of finishing being $800, finish up being $8. And so that's what people do. And basically, a computer in a chip is a thing that already exists. And so the whole idea of the cloud is very large storage. Where do they put these things? In cold places. Alaska, Seattle, Siberia. Why?
You gotta keep those server cold.
Major cost is
The cooling the server.
air conditioning, because those things heat up. One of the major costs. Now the other thing they need is good broadband access. They need very good telecommunication access. And they can't rely on one particular access. They need at least 2 to back it up, maybe more. Because cables do go down, less than computers, but they go down. And then typically these big sites run something like Hadoop or something, which is an operating system. And when you use, for example, we are reciting the Rutgers accounting web, which you eventually are going to hear a lot about, called Raw Rutgers EDU. And what we are doing is we're putting it in one university computer on Hadoop. And actually the computer reciting is a virtual computer. There's many computers below it that create a virtual computer. And that's the kind of thing that they do in this large storage spaces. So if a particular device that you're using dies, you don't even know. Because the operating system had distributed your data, it distributed the application, and rapidly moves you over. And so this is the idea of the cloud. And you know, it's a very interesting reversal of thinking. Because how did we start with computers? We started these huge computers in large locations, one big computer. I bought a computer, I didn't buy it. Brazil bought a computer where I was a director. And the thing called $4 million, okay, had 1 megabyte of core. It was nothing, okay? And when it crashed, it crashed. Okay, now with $4 million, you buy a lot of computers. Mainframes, supercomputers, and et cetera, et cetera, et cetera. So you can't even compare these types of things. However, there was this whole period of 30, 40 years that computers were very large devices. And then somewhere in the 60s, late 60s, people started rethinking, so this idea of getting a big deck of cards and running to a card reader and etc. might not be a good idea, maybe we can do it differently. And so they started to develop this idea of a time-shared computer. And what was a time-shared computer? A computer in the middle with wires out there and terminals using it. So gave you this feeling that while you are in your terminal, you are the only user of the computer. But in reality, there were hundreds of people using it. The big commercial application that gave birth to this was airline reservation. And in the late 60s, a group of airlines put together a consortium, and they said, well, you know, this whole idea of having a person filling up a piece of paper because Sophia wants to travel, and say, she's going New York, Chicago, Sophia here in this seat. And that's the way they did it. You would pick up your telephone, and call up a reservation clerk, or you actually would call your travel agent, who called up a reservation clerk, and the reservation clerk called up Chicago for the return. So it was really a pain, correct? And so they said this is a natural application for one computer, many people connecting it. So they put this thing together, and what happened is that they couldn't resolve the technical problems, or they fought between themselves because they were competitors. So American Airlines pulled out of this, created a partnership with IBM, and they adapted the computer, which was a IBM 36044, into a time-sharing machine, and they resolved the 2 or 3 problems that they had to resolve. They created more efficient storage, they created multi-drop lines. What is a multi-drop line? 3 of them can call up on a telephone, and the 3 of them will connect into one line because it was packetized, and then we'll distribute in the other side. And there are a couple of other things they resolved, and they created a thing called Sabre, S-A-B-E-R. And Sabre was the reservation system of American Airlines, and American Airlines, over the years, before they divested of it, made more money out of airline reservation than they made out of flying planes. And actually, if you use Orbitz today, do you know what Orbitz is?
Yeah.
Orbitz is Sabre, or a version of Sabre. Okay, and then many airlines went in with their reservation systems. And remember what I talked last class. You put a computer in a room with guys with machine gun around it and no remote access. You are very safe, but it's not very useful. Now, these guys put wires out. The moment you put wires out, what happens? Someone that is not allowed might come into the wires. And at the same time, the way the first business model was, they sold terminals. They actually typically didn't charge for the terminal. The terminal went for free. The travel agents paid $1,200 a month at that time for access. Was it worth? Of course. No phone calls? Great. And there was a time they had 1,000 of those connected into their Sabre system. And progressively, turns out that the development of these things was very expensive. And so there were many competitors to Sabre, but actually Sabre occupied a large part of that market. And then they realized that only having, for a while they tried to hold on and say, only online reservation is with Sabre. So American Airlines did very well. But progressively, clients said, I want to fly with Delta. I want to fly with another company. And they created their reservation systems. And then some regulatory authorities say, hey guys, don't do monopolies here on me. And so they started interlinking these things. And progressively they interlinked all of them together. And there are airlines that are not on the interlinked system. There are few airlines in countries, you just have to call them up. Is that good or bad? It's typically bad, but has its good things too. And so Sabre was this big application, and what there happened is many people using one computer. And then continue growing computers doing this, that. And then this story about the personal computers appeared. And there are a lot of people saying, why would a person need a computer? You know, you have these big computers doing great things. These little hobby things like Commodores, etc., don't do very much. And that's why IBM, for example, didn't go into the PC business until they realized they had a deadly mistake. And the wave started converting to using personal computers. And that's the generation you are in, and you are just changing back to using big computers, because the cloud is a big computer. It's not like what we thought before as a computer being, but it's really a huge device that you get a little piece of it, but you depend on that other side. I don't like my pictures, but maybe on the web, maybe I'm old-fashioned. But I bet you most of you will put your picture on the web without even thinking about it. And sometimes you have your pictures on the web without knowing they are in there. You put the application in, it connects on the web, Google gives you space, everyone gives you space. From one second to the other, you're using space. And then they try to charge you for some of the extra space, and then you start realizing your pictures are not with you, et cetera, et cetera. So this is a whole type of thing. My wife has a lot of problems with her pictures being on her smartphone. Why? Because she takes a lot of pictures and fills up her smartphone, and then she doesn't know what to do with it. Okay? And I don't want to be tech support in my house, because that will be every 5 minutes. Okay? But you know, you have to resolve those problems, and of course, technology comes to a point that they resolve those problems. Last thing Apple wants is everyone calling, what do I do with my pictures? So they have to automate these solutions. And every time you create a good thing, you create also a different thing. Now, this is actually an old slide, but a very old slide, but it talks about sizes of storage and et cetera, for the cloud. And just the size, the increase of size of storage these days is mind-boggling. Now, for you, it doesn't boggle your mind because it's just one more digit or two more digits on the exponential equation. But I remember at Bell Labs about 15 years ago, a friend of mine making an estimate of amount of storage on the web. And the entire web in the world had about 1 petabyte. Now we are talking about zettabytes. Okay? And it's nearly not understandable what these numbers are. Okay, now this actually from The Economist is a nice definition. Computing clouds, essentially digital service factories, are first truly global utility accessible in all corners of the planet. Now I want to give you an analogy. The analogy is power. Okay, when you started generating power for machines and et cetera, the beginning was what? You had a generator, and with wires you connected it to your device. And so there was very prime real estate to be close to a river. Why? Because the river moved your turbines generated electricity, and you didn't pay per megawatt of electricity. But you had to be reasonably close to the generating plant. And they kind of made it farther and farther and farther. And you know, Thomas Edison was a great genius on doing this. And Thomas Edison created the power plants in Manhattan and started wiring everything. And he made a big mistake. He opted for direct current as opposed to DC. He opted for DC as opposed to AC, alternate current. And then one guy that worked for him, Mr. Tesla, created alternative current and basically created the utility. So you didn't need a generator of your own. What you needed is connection. So it became a utility. And what we are happening with computers, with this stuff, is basically a utility. You're going to plug in the wall for getting your computing and use the product. And by the way, you're all using computer utility without even thinking about it. Google is a computer utility. And you have what you have in your device is basically an interface. And there are huge clouds of computers that belong to Google that do your computing for you, meaning finding information, and then deliver the result to you. And as you know very well, no internet, no Google. Yes or no?
Yes.
Can you have a local Google?
Sure.
Sure.
It would be Google in the sense of what Google's now, but it could be a very miniature version.
No, it couldn't, because the storage, to be any efficiency, you have to have a lot of information available. Now, you're right, you can have a Google interface. You can have the browser, and you can have the Google application sitting on. And these kind of applications have the local part of the application and the remote part of the application. And so what you would have is the local part of the application. And the other thing is local and remote. Certain applications do a lot of things locally. you use Dropbox, you are disconnected from the internet, you still can use Dropbox. It works autonomously quite well. The only thing it doesn't do is what? Share. Okay, and doesn't update your Dropbox. When you go in Dropbox, there is local on your disk drive, and there is cloud Dropbox. If you lose the connectivity, what you change here doesn't update there, and you can't access something that you made invisible there, or if I'm using it together with Unkit, Unkit's update to a paper we're writing together doesn't get to me until the connectivity goes. And the nice thing about Dropbox is you don't notice this, except your little icons next to the file or the folder, instead of the regular color, turn red. I think the regular color is blue. Turn red, saying, oh, I didn't update when I should have. But the moment you get the connectivity back, it starts working. It's very nice, actually. It's very well done. They are among the world's biggest energy hogs and thus account for a lot of carbon dioxide emissions. More happily, they allow firms in developing countries to leapfrog traditional information technology and benefits from advanced computer services. Now, the thing I like more to talk about this is our digital library. Half of the users of our digital library are in other countries, typically English speaking, because our library is all in English. But they are getting advanced courses on PhD level and master's level for free. And it's pretty powerful, correct?
Yes.
This is going to be very leveraging over time. Although they talk about the digital divide, have you ever heard about the digital divide? The digital divide is the people that have computers and the people that don't have computers. And if you live in Africa and you have a $1 a month income, it's difficult to buy a computer, correct? If you have $100 a month, still it's difficult to buy a computer. But there is an equalizer now happening. What is the equalizer?
Smartphones?
Smartphones, absolutely. Smartphones came in, and there's a big equalizer, and they share the smartphones. And so farmers in Nigeria, away from the main place, can basically sell their crops from the village cell phone. So it's very interesting how these technological innovations can help. Okay, and they actually talk about this. I don't find this terribly useful, so I'm going to go through this very fast. They have kind of three types of cloud service. One, they call it software as a service. Then they call it platform as a service, and then infrastructure as a service. And these are kind of three ways you use the cloud. The only thing you're really interested in yourself is having access to the cloud, either for backup or for information that you're trying to get. Okay, so this was the basic technology. I just want to recap with you for a second some of the key things here. Okay, because you are going to realize most of you are technical enough that you knew some of this, but pulling the story together is very useful. Okay, you have a low-end device, which is your PC. This particular PC, or your cell phone, this particular PC used to contain all your information. And now, this particular PC is probably one of your major sources of telecommunication. You communicate with it, and is sharing your information from a cloud-based device. And very often, when you are using a cloud-based device, you are not paying for it. Now explain me, how can Google be the leader, one of the most valuable companies of the world, and not charge you for a service?
Advertising they receive from
You see, advertising is not such a big business, but it is a big business. Okay, so one of the sources, and why don't they charge to you?
They sell the data of like what you do in the internet.
So that's the second thing. Besides advertising,
Okay.
they have analytical applications, algorithms, that they can sell to many people. Okay? But why don't they charge for the usage?
In order to get market share.
Because without the data, they couldn't run the program, like the algorithms. They need the data to keep moving.
I think
Like
if
we're
they,
providing them with that.
I think you're right about that. But I think that if they could charge, they would. Okay, when they started, Google is not very useful if it doesn't have a lot of information. Google is not terribly useful if there are not a lot of people using it, because they get a lot of information out of that. And so the model had been very often, this business model, accounting, etc., business model has been private people don't pay, companies pay. And that's still true to a certain degree. But Google would haven't been this monster that they are now if they have charged every person for every query they did. Just imagine how much money they would have done. However, if every time you go in Google and query, you had to pay them 10 cents. Say 10 cents is nothing. Do you think it's nothing, Gloria?
I think it would add up really fast.
That's right. How many Google searches you do a day? I already asked you guys to do 2 or 3 today here. Okay? You do a lot of Google searches. And by the way, Google will be much less useful because there'll be much less people connected. They wouldn't have developed a big database. And what is the problem of the other search engines? Most of you use Google. Does anyone here use something different than Google?
Only by accident.
Ask.com?
No, by accident I will.
Oh, by
They
accident.
were asked,
Yeah,
like,
you could bring
Yeah.
it in.
Actually, Stephen, remember the accident? I want to talk about that for a second, a little bit later.
For if you go to different countries, I mean, Google might not be as accurate as it is in US. In Korea, I use different search engine. But if I look for like academic information, of course, Google is the best. But other than that,
Okay, so there is a geography to search engines.
yeah.
But of course, the search engine is the better if it has more information. And it has more information if it collects spiders to the web and picks up information. And at the same time, there's a lot of information about you because it helps them to organize your interests. Okay, and of course, the purpose was to become ubiquitous before anyone else was ubiquitous and dominate that market. And the search market is the overlay market on PCs at this moment, and et cetera, et cetera. But they are not going to stay that way. Eventually there'll be another very hot type of thing. And of course, the things that we talk today is not only Google, we talk about Facebook, we talk about many different brands of things. And let's see what's the next one. If you knew what the next one was, what we would do, become millionaires very fast. We don't mind that, do we? But back to Google, so this became a very different thing. Think about 30 years ago, what product did you get for free? You say water from the government. Not the government, you're paying the government, paying taxes, so it's not free. And since the internet came, you get a lot of applications for free and etc. And little cost accounting comment that we made last time, I like to reiterate it, is most technological applications have big startup fixed cost and very low incremental cost. It's not like making a shoe. To make a shoe, you need all these implements for every new shoe that you make before you sell it. And actually, I am actually surprised that Apple does so well because they sell devices. The ideal world is when you are selling something that has no incremental cost to you, when you sell it again and again and again. But Apple around its fixed devices, is now selling a lot of things. How many of you have never bought anything from the Apple Store? You. Never downloaded the music from the Apple Store? Someone needs to teach him how to download.
But incremental, you mean variable?
Huh?
When you say incremental cost, you mean
Yeah,
variable?
variable cost. We have a cost accountant in the group here. Yeah, but that's actually the reason why, for example, Google can provide the services they provide. Also, the magnitude that they have, Apple, Amazon, and etc., makes the larger the setup is, the base cost, the incremental cost of running things tends to be smaller. So it's really a cost accounting story. I wanted actually to say one more thing on technology. I just need to find my slide. You know, people are saying that this is the age of the algorithm. And I just wanted to go to these slides. I don't think I have these in my slides. Remind me to put them there. Maybe I have them. Okay. Why do they call it the age of the algorithm? Do you use algorithms every day? Yes. Every time you look for something in Google, you're using a big algorithm. Do you use Google Maps?
Yes.
Do you using an algorithm there? Waze? Yes. Do you buy over the internet? You're using a lot of algorithms there. And it's very interesting. You always thought, most people, lay people think algorithm is for mathematicians. But all of you are using day after day, minute after minute, algorithmic allocation things, algorithmic usage. Okay? And I just want to give you some examples of these. These are really interesting. Case studies, City of Boston. Some of the earliest adopters of the IoT. We talked about it last time. What is IoT? Internet of Things. Okay, and the intuitive thing about Internet of Things is linking devices that you have in your house. Your thermostat, with your refrigerator, with your car, etc., etc., etc. Hundreds of devices that can be linked. Every day they're getting a little bit smarter, and maybe they can do something else. If you have a Sonos sound system at home, you turn on your music. You choose the music that you prefer. That's a great algorithm. And you go on from that. The Pandora looks at the type of music that you ask for and decides to give you analogous music that you will like too. This is all algorithm. The City of Boston, some of the earliest adopters of IoT have been municipal governments. Boston with a number of high-profile university labs, MIT, Harvard, and tech startups has been one of the most aggressive adopters. In traffic and parking application, the city has partnered with ride-sharing startups to monitor real-time data on traffic backup while also supplying information on road closures and parade routes to these companies' online map. Does this remind you of something? Online maps, traffic. Waze, of course. And remember what we talked about Waze last class?
Yes.
Waze is a group share application. What does it mean? Your information feeds Waze. And so everything what they're giving you is a pick up your information, chew it together, spit it back on. Why do you guys use Waze, not Google Maps? Google owns Waze, and they paid something $1.1 billion. And why did Google buy it?
Sort of like it's like technology, like, so we have access to, I guess, like the programs they
You are right, basically right. But they wanted the capability of Waze to estimate times on top of maps. And they are kind of parallel applications. Have you realized that? Meaning, Waze without a map is useless. How many of you never seen Waze? You should. Download it for free. Remember, it's a Google map, Google application, don't charge money. Little Israeli company developed it. After 3 years or 4 years, they sold itself for $1 billion. Not bad. Okay, so they bought it basically for the group sharing technology. They incorporated some of the algorithms into Google Maps, but they have a lot of difficulties because it was a very different type of technology. Now, Google also does this kind of group where type of thing because they get a lot of information from users, but you are less aware. Ways you know that you are driving somewhere, you are basically informing the network how the traffic is flowing in that particular way. And so they are kind of, and interesting, I always thought that Google was going to kill Waze and just incorporate it into maps, but they didn't. They keep it separate, and they must have their reasons. I haven't quite figured out what it is. And so this is actually parallel. And there was an interesting article in The Economist talking about the need for maps and the need for several suppliers of maps. And you start thinking about this. The other thing is the old maps were not good enough. The resolution is not granular enough. And so they have, Google is remapping the world pretty much with better resolution to be able to find things in a more accurate way. And everyone is competing with that because, turns out that the market for mapping is very large. And have you ever thought of how the Russian government, the Chinese government, the North Korean government feels about mapping? There are military reservations in Arizona that are the size of Rhode Island, or that big, very large. And this was secret 50 years ago. Now you know exactly where everything is. And actually there was a time that countries were contesting the US satellites doing geo-mapping. And just imagine how these countries feel about a car going around taking pictures for street view. But this is a temporary problem because mapping is a modern technology very necessary for a thing. And I always talk about mirror worlds and real worlds. Okay, the real world is where we are at this moment. The mirror world is something that copies some feature of our world. And Google Maps is a mirror world. And when you're walking here and your cell phone is on with the GPS feature, it's telling the mirror world where you are. It's that linkage between the two worlds. And that linkage allows all kind of analytic applications that are extremely convincing and extremely important. So what they are here joining, parking, and that's not in maps. But if you go around Europe, in many cities, you can drive into a region and there is a board there saying such and such parking place has 30 seats available, this and et cetera, and so on. They have a sensor in the parking place. They count how many cars, how many available. So you don't go to the wrong parking lot. Particularly the cities that have a center of the city constrained to traffic. So to go to the city, like Florence, for example, you leave your car in the boundaries if you're driving, or take a train. But if you take train, you don't want parking. You leave your car in the boundary, but before you leave it, you see what's available. In the US, you don't see this very much. Some cities have a little bit of that. But it's linking different type of things. Meanwhile, a citizen can find empty parking spot using the smartphone, then use the phones to pay for parking. And Waze is giving strict conditions. Drive with Waze, it tells you There is a car parked in the street, there is a policeman watching, etc., etc. These are very often self-reported type of things. Okay, and then this is kind of interesting. Many years ago, I wrote my dissertation, Man-Machine Planning Systems. I was talking about coexisting man and machine and etc. Now this is a constant discussion. Complementing one another, there are likely to be a variety of ways in which smart people and smart machines will work alongside each other. Some humans will have to build and implement cognitive technologies, of course. Others will ensure that these technologies fit into a work process and monitor their performance. And some humans will complement computers while machine can't perform. So we have this consortium called Radar, and it's basically to provide analytics to the audience. Okay, what is the big concern that CPA firms have with algorithms, with the usage of analytics in auditing?
They might firms, but for us, I guess they might take our jobs.
Absolutely,
Yeah.
and the firms are worried about that too. What is the billing model on a CPA firm?
Is it hour per hour?
Hmm?
There's a billing.
It's typically by billing hour. Yes, so many juniors, so many seniors hours, and etc. etc. They bill that way. Although the model is migrating more to a package kind of thing, that size of this firm and this industry will charge so much for the audit. What happens if the entire auditing world, don't start crying, becomes totally automatic? The billing model disappears, okay, and allows for Google to get into the business. Now, what happens if they don't invest in analytics?
They get behind.
Huh?
And if somebody else enters market with that technology,
That's right. They'll be able to compete in beneficial terms. Less labor, more work. Can you imagine if every auditing firm is just one big machine?
Free.
A new product for auditors is cybersecurity. Okay, every company has great concerns with cybersecurity, and the public and the investor would be very interested to know if this particular company is doing the right thing in cybersecurity. So ASAC, which I mentioned last time, is creating the cybersecurity principles and criteria to allow Matt, working for a firm, to examine those principles and criteria, compare with what the firm is doing, and deciding if you can issue an opinion that cybersecurity here is good. But do you think you guys are competent to issue a cybersecurity opinion? Do you think you are competent, Matt?
Not at that.
Right. And we don't teach cybersecurity. I'll have one class on it. Okay? And so what's going to happen? Other companies that are specialists in this will compete. Now, they are not specialists in issuing assurance opinions, but they are specialists on the technology. So either we migrate our product, or someone will eat our sandwich. And so we are creating principles and criteria, and of course we would hope that the government comes in and requires a CPA to issue a cybersecurity certificate. They are not going to do it, but I shouldn't say they are not going to do it. It's very unlikely that they are going to do it. Okay, but this complementarity between man and machine is a big deal. Okay, now the other thing, this is our last lecture, we're going to talk about creating businesses based on technology. And very interesting thing, there was this peak here of investment with startups and etc. And then look what happened. And then there was this little peak here, and look what's happening this year, and this year even less. Actually, this here was bigger, much bigger. This was just a partial thing. And why this kind of venture capital investing is so oscillating?
Isolated, you said?
Oscillating.
Oh, okay, oscillated.
Why does it, it's not a steady stream. What happened here?
2008 financial crisis.
No, before that, the 2003 internet bust.
Oh, yeah.
Yes, is where Enron happened, but except many startups went bust at that time. And here this kind of whole irrational exuberance, as Greenspan called it, happened again, and now they are kind of consolidating them.
It's oscillating, but early investment seems like it's still less oscillating than the late investment. So maybe a lot of those are the times when a lot of companies are making tons of money, so everybody's jumping into that bandwagon and making money. And then when the market bursts for that particular industry, then people just stay away from investing in venture capitals, perhaps.
So it's kind of a psychological thing, isn't it? It's really mainly a psychological thing. And actually the form of venture capital funding has changed dramatically. And we'll talk about it the last day of class. Okay, now this is the chart that I picked up, and it talks about the replacement of people by machines. And that McKinsey has a much larger one that I can sometimes show. And look at this, sales and customer services occupations, elementary occupation, carrying leisure and other services, secretariat, industrial. This is where we are, skilled trades and occupations, technical occupations, professional occupations, okay? And it's very clear what the story is the more repetitive a particular job is more likely that will be automated. And the other part of the story maybe is a little bit less intuitive, but is real too, is there is this interchange between repetitive jobs and decision making. And auditing is full of decision makings because the variables are too many. But eventually, certain audit decisions are automatic, and those will be automated first. And the difficult thing in audit research is to figure out what will be automated first. And the pressure is what Andrew said here. Ideally, we are making a lot of money in auditing these days. Let's stay with this work. But in reality, there'll be tremendous pressures that other people will be entrants on these markets, and if you don't automate to a certain degree, you are going to disappear. I met yesterday, just happened to be met with, I was in DC yesterday, and I met with a retired partner of PwC. And this guy is called Mike Willis. And Mike is now assistant chief accountant or something like that. But he's in charge of XBRL. Do you all remember what XBRL is? Oh, the memories are so short here. I'm going to put another reminder later. Extensible business reporting language and extensible markup language. What is XBRL? Is a derivative of XML. Has happened in XML has derivatives, 300 or 400 derivatives in different industries. This is our XML. This XML that you represent financial statements on, and I'm trying to convince Mr. Eric Cohen who's national leader of XBRL for PwC to come here and talk to you. And he's done this many times. He loves to come. We just have to find a date that he will come. I don't want to pay his airfare from Rochester. So from Syracuse, and so from Rochester, and so I have to find out when the PwC has something to be done on Wednesday here, so I can bring him in. Okay, but Eric was one of the original developers of XML, XBRL FR, and XBRL GL. And that said, XBRL FR is financial reporting. FR, we talked about it last time. And what is that? You pick up your financial statement that's on paper or magnetic, and you pick up the key numbers and create an XML, XBRL statement that you can distribute. And every large company in the US that is in the public markets have to create, in addition to a paper financial statement, it needs to create an electronic financial statement with it. And this week, a big development. The SEC created a pilot program for a new version of XBRL. And this version of XBRL will be embedded into financial statements. So you publish a financial statement, there is information behind it, and with the correct browser, you can pull it out and show it. And this is exposure draft. It's going to be an experiment with companies, and maybe in the future, the government will require it. And what Mike Willis, I was asking him, a research project around this. We have a kind of a problem with Assurance Service Executive Committee, a big problem. And the problem is the following. How do companies get an XBRL statement? Some of them go and train Andrew to do it, and Andrew can do it. Actually, in the early days of XBRL, I had a PhD student trained to do that. She got a Fujitsu tool for free. Eric told me to go with the Fujitsu tool. And she created W.R. Gray's XBRL statement. And took her maybe 2 days to learn the tool, 2 days to put together the XBRL statement. Okay, smart, she's smart. Okay, but companies now hire people to render the financial statement. They pick up the data from the financial statement and put it in XBRL, and they pay between $5,000 and $20,000 to be done. It's expensive, but not exorbitant. Our committee did a study on this and wanted to make auditors certify that the financial statements in XBRL correct. And the product would be something like 200 audit hours. 200 audit hours is $100,000. So you prepare an information for $5,000 to $20,000 and cost you $200,000. You think this is going to fly? No way. Okay, so go ahead.
Is XBRL only for financial statements?
Yes.
Okay.
But they are using for Internal Revenue Service in England. They are all kind of, the core report of the control of the currency is actually XBRL.
Like instead of just, I don't know if it's a dumb question, but like could they just create
Guys,
solely
don't
an
say there are no
XBRL?
dumb questions. Questions are
I
to
don't
be
know if
asked.
this doesn't make sense, but couldn't they just create the financial statement in XBRL like language instead of the statement and then the XBRL? Or is that
In theory, they could do that. You could spit out a financial statement from SAP and get it in XBRL pre-programmed. Okay, but the reality is when the financial statement data is ready, lawyers look it up, adjust it. Public relations, CEOs say, I don't like this, try a different accounting method. Accounting joke, apologize for it. 3 people are applying for a job. The controller's interview. So he goes for the first one and say, how much is 1 plus 1? The guy says, 3. Yes. Obviously he doesn't get hired, gets gone. Calls the second one, it's a pretty young lady, and say, how much is 1 plus 1? She says, 2. He said, let me think about this. Third one comes in and say, how much is 1 plus 1? He answers, what do you want it to be? He gets hired. We have a lot of accounting jokes. Okay, obviously there is a reason for that, correct? Is that management wants to show the best face they can or certain results they can. Accounting standards allow a lot of latitude. And I mentioned last time that companies tend to use this flexibility to show what they want to show. But if the things are going bad and going bad and going bad, it comes to a point that there is no more flexibility. Then what happens? If a company is Enron or WorldCom, they cheat. If the company is AT&T, they do the big bang. And what is the big bang? They do a big write down, write everything down. And that gives them some more movement for a few years. Ask Professor Sanella about this. Okay? And he'll agree. He'll agree. There are a lot of studies of big bangs and etc. But this whole thing of automation is going to change this whole scenario, and you are going to, I tell my PhD students, tenure is progressively disappearing. But their generation is still going to get, many of them are going to get tenure. Okay? You are in the generation that many of these things are going to change, and it's very important that you remain technically able. Because a lot of things in the future are going to be computer-based, decision automation, and you're going to work on the tip of the iceberg. And I'm going to have a couple of our students come here and present decision support system that they are doing for audit planning and etc. Finishing just the story of talking to Mike Willis, I asked Mike Willis the following question. I say, isn't the solution to auditing an XBRL statement creating an automatic XBRL statement? A couple of you already picked this up. You even asked me that question. And comparing with what the company is saying, and he said, yeah, that's a very good idea. I think you can do that. And by the way, at PwC, this is his memory for the year before when he was part, we actually are recreating financial statements by looking at the ledgers, extracting data, and they say, he said they were at the 30-40% completion stage on that. So you see, and PwC is investing a fortune in technology. The numbers they talk about, $200-300 million, a lot for remember, for a partner, every dollar they invest in research is a portion less of their pocket.
It changed.
Huh?
I think Professor Sanella said it changed. They're now companies are spending less on R&D because they changed the rules, so it's now considered as cost, I think.
Well, that's companies.
Yeah.
And they this FASB 5 and etc. But actually CPA firms are back to spending much more money in R&D. And what they are spending money, and this is a worry I have about you guys, or maybe not you, but our undergraduates more, is I'm a little bit worried, or very worried, that these firms are hiring data scientists, they're hiring statisticians, they are hiring modelers, algorithm builders, and they are not hiring my students. And every time I go to Professor Palmer or Professor Zanella, our leaders here, and I say we have to put more analytics in the program, have to put more computing in the program, the answer is there is no place in the curriculum. PA is particularly constrained because you guys get an MBA and you have to have all the accounting courses. But the advantage you have is that we have been here for a long time, and we inserted a lot of technology in your first audit course, your second audit course, in the audit, and in this course. But the undergraduates don't get this. And they could be obsolete very fast if we don't take care of it. Okay, so this is what I said to you. Our algorithms are already all around us. Google's proprietary algorithm is the driverless car function, is in the driverless car functions as the connective tissue that combines the software, data, sensors, and physical assets. Now, this car, this automatic car, the self-driving car, I am fascinated by it. When is it going to happen? We already talked about that. It's happened already. Correct? Meaning Google, I think I mentioned last time, Google has over 1.5 million miles driven on their automatic cars, 2 collisions that they have announced. What is this thing? Is it a little robot sitting there going like this?
Cloud? Is it cloud computing? Is it part of the cloud computing?
It's a mix of things.
Okay.
It has sensors in every direction, correct? And the sensors can look at the left, can look at the right, can see if you don't hit when you're backing out, and some cars already have that feature. Okay? Has cameras, and the cameras are linked to algorithms, and is linked to maps, and all of these are put together. Now, is this a smart car? Is this like a person? Or is it smarter than a person?
It has some of the capacities of a person, but it doesn't have the decision-making capability.
Yes, but it decides in 1 millionth of a second, while it would take you a second to do certain things. So it doesn't have the capabilities, but have sensorial input that is much faster than you have. So you rather go in a driverless car or a car driven by my wife? I told you, don't say ever to her what I say. Would you like land in an airplane with a pilotless, with automatic control, or you want to land in an airplane with a pilot driving it? Most people will say, I would want a pilot drive. But that's changing, and now I'm getting some students going, I actually want, I want automatic pilots to land. Okay, and of course this question applies everywhere. Do you want an audit by an individual or an audit by a machine? Do you want a doctor to diagnose you, or you want a computer to diagnose you? And what do you want?
Well, for doctors, I guess, for just minor illnesses, I would definitely use the machine because it's probably cheaper to do it. But if I have serious illnesses, I'll probably want a doctor to take a look at it. But once like the technology develops and they're better than the doctors, then I'll probably go to the machines.
Better is a relative term.
Yeah.
Okay,
yeah.
things have many dimensions, etc. But interestingly, Andrew kind of mumbled around, but he talked about the key type of things. Talk about quality of the work, talk about the seriousness of, in this case, the disease, and then he talked about the economics of the thing. And remember about the economics with digital goods. The startup is very expensive, the usage is very cheap. Now, how do you feel if you go to a doctor and you go in and he says, I have a stomach, you say, I have a stomachache, he types it in. And then everything you say, he writes it in. Okay, and when he decides on a diagnostic, he goes into the internet to find what medicine to give you. How do you feel about this doctor?
He's no longer a professional.
Oh, and is it good that he's no longer a professional or bad?
Well, good and bad. I mean, doctors, they take out all these big student loans, have to pay all this extra money.
They need to make money.
Yeah. So, I'm not going to be paying any less for a doctor in the near future.
Last time we talked about memory, about examinations like CPA, that all this information we remember and then we forgot it a couple of years.
Yeah.
So same with doctors, all the information that's on this call, there's some.
But remember, memory and doctors. If a doctor sees a paradigm, does a good cure, he'll remember it. But if you tell the computer about that, 1 million people will remember it. Okay, so it's a sharing effect there. And the other thing is you copy a doctor, maybe you'll be copying the wrong doctor. And he'll kill everyone. No, just kidding. But I mean, the reason of this discussion is this kind of man-machine paradigm discussion. And the other thing that we talk about this is combining sensory functions, memory, rapidity of decision, and algorithms. they all come together. And the more you work in your profession, which will be the accounting profession, you see more of this kind of thing. I have been very strong on arguing for changing the CPA exam, but more of it is this idea of getting CPE credits. Because at this moment you can go on a wine tasting tour, on a cruise, and get CPE credits. Now you could argue, it'd be late, but you could argue that you learn wine tasting, you get more business because you take your rich clients to drink wine. But that's kind of a lame argument, correct? On the other hand, auditors and accountants are not learning statistics, are not learning modern technology, and this is changing in 10 years. It will be very different. And what I taught you will be totally obsolete. Maybe the FASB didn't change a lot of rules in 10 years, but I guarantee you that the technology I'm teaching you will be old technology. And so the only reason to have CPE credits is to have a lifelong learning and updating thing, but not that you take whatever you want, but there must be some people that will tell you that you need to learn, when you're a senior, you need to learn analytics. When you are a partner, you need to know decision science and tools and whatever the things are. Very, very important. So I talked to you last time, just reminding you the term piggybacking is mounting many technologies one top of the other. The other one is I just wanted to bring this high frequency trading algorithms. You know that over 80% of the trades in the trades in the stock exchanges are automatic now. What is the implication? What is the implication? I haven't heard your voice yet.
Sorry?
Dwayne.
Yes.
What is the implication of the fact that 80% of the trades are automatic?
It just means that, I guess more companies want to save money. More companies.
I'm totally right. People save money, but is that the main implication? What are implication of this automation? The first thing is, you think it's fair a man competing with a machine? Actually, there has been a lot of discussion in the standard setters of what the trading machines are allowed to do and what a person is allowed to do. And they think that the trading machines are getting information before people. And they are very worried about that. And it's automatic, meaning I was asking you about speed of decision making. It's automatic that you, Sarah, and the machine gets information. At the same time, you have an algorithm, you just apply it before we can even think. The other question, Sarah?
Yeah, but isn't the value of a stock based on what people evaluate a stock? So how can computers be allowed to
So
evaluate?
the value of a stock is a composite of different things. What are those things? What you said is totally right, meaning how many people are interested in it.
Right.
But how do you get interested on a stock?
The profitability of the company.
Okay, profitability of the company. There is intrinsic items of what that particular company is doing. Correct? There is a basic that is performance. We hope it's not. I mean, they say that a lot of the Chinese stock market is pure gambling. Is that true? I'm not going to quote my wife. Is it true? It's more true than in the US because the financial statements are much worse and much less reliable. In any emerging country, you have that phenomenon. Look what happening in Brazil at this particular moment. And of course, if the financial statements don't reflect well what the company is doing, how can a trader discover how the company is doing? So there is these two composites, a popularity type of composite, information, public relation thing, and some basic thing that the company is doing well or poorly. Meaning you will have a lot of difficulty saying that Google is doing poorly. And people are now saying Apple is doing terribly. Is Apple doing terribly? If I ask you to raise hands, I bet you half of you or more will have an Apple phone or an Apple device in their hands. Are they doing poorly? Maybe they are not growing the way they grew before, but it's inevitable. Any company with this type of scope comes to a point there are not enough people, so you can't sell as much. Now, I was going to do it today, but I'm kind of running out of time. I'm going to show you a few of Mary Meeker's projections. It's in your materials. And you know what Mary is now saying? She has been doing this analysis for a long time. She's with an investment firm. And she's saying that, like the growth in internet and the growth on cell phones has kind of petered out. Because it was growing 40% a year, and now it's growing 8% a year. Now it's 8% a year petering out. I wish AT&T or Verizon had an 8% growth in sales every year. I would make a lot of money with them. It's just a question of seeing it. And this is the hockey stick story that a lot of analysts go on this. Company goes like this and starts growing. And of course people expect a straight line in extrapolation, say they're always going like this. And when they start going to the regular, let's say, economy growth, they think this company is dead. That's what is dead. It's not true. It's just going to this. And what's going to happen with those PE ratios that we talked originally? Does everyone know what the PE ratio here is? You divide the price of the stock by the earnings of the stock. But not all the earnings of the stock by the price of a stock, but earnings per share divided by the price. Well, actually, it's the earnings in one share divided by the price. Okay, and when that multiplier is very big, you expect a little increase in earning to make a big increase in price. And that happens at this stage here, but it will not happen when it stabilizes. What's going to happen is that the abnormal growth of this firm goes down, and its PE ratios is going to become more natural. The PE ratios of places like Amazon or Apple now a little bit less, Google, are ridiculous. But if you're smart and can get out of it in time, you're good. You're very good, you're very rich. Okay, the opportunity, monetizing. The opportunity will first center on monetizing the proprietary algorithm by offering licensing and to other non-competing organizations. For example, a supply chain company can license a just-in-time logistics algorithm to a refrigerator manufacturer that seeks to partner a grocery chain, to automatically replenish food based on your eating habits. Why invent or slowly develop sophisticated algorithms at a huge cost when you can license? And of course, this is the whole thing. And this is like accounting, like auditing. The rules of patents, licenses, were developed in the last century, and is trying to deal with the current problem. The market for it will inevitably create entire new markets to buy and sell algorithms, generating significant incremental revenue. Imagine a marketplace where billions of algorithms are available, each one represented a piece of software code that solves the problem. I was driving home from Long Island, and I have Waze on, and I had my Accurus map thing, and I wanted to put Google Maps on too, but I only had two devices in front of me. And I was kind of thinking, do they have the same algorithm or they didn't have the same algorithm? And then I started thinking, what other devices, what other software have competing algorithms? And then you start thinking about that. It's a whole set of algorithms. Is a traffic-related algorithm? Is a location-related algorithm? Is a time-sensitive related algorithm? Is a predictive algorithm or not a predictive algorithm? Now, I'm driving, and it tells me that at this particular moment, it will take me 1 hour and 3 minutes to get to my home. And I was kind of thinking, is this something that is reflecting today's traffic? Or is this something that has looked over the years and seen how a Sunday afternoon or Monday afternoon traffic changes, and already looking for what will be the traffic at 6 o'clock in the afternoon?
I was gonna ask you, like, whenever I go to my parents' house, I mean, I don't think it's any particular time, but like, I'll get in my car and I'll look at my phone before I start driving, and it'll say like 9 minutes to home. Like, how does it know I'm in my car and I'm about to go home? Like, I guess it like has the GPS coordinates of my parents' house, and then how far I've like labeled my home address as home. Would that be an example? I guess that would be.
Oh, it's a very good example.
Of an algorithm.
Just
Or
go a
even
little bit.
in the morning.
Just go a little bit
everything
farther
is
with
just
that,
here.
because just think, how does it know you're driving a car?
I don't know. Like, I got into it, but I
Just-
hadn't like turned it on yet. I just like looked at my phone and it's like knows I'm going.
So
home.
how does it know that she's in a car?
Be connected to Bluetooth.
Huh?
Maybe when I maybe as you turn it on, maybe the Bluetooth.
Maybe by default it assumes that you are in the car. Maybe it measured your GPS positioning
Like in the driveway.
in the driveway and figure out. And I also wondered about this, is how do they estimate the time that I'm the LIE?
Yeah.
Okay? I kind of was wondering, how does it think of that? Does it think differently? Meaning, I'm raising the problems here, just for you to think about. Go to you 1 second. I was thinking, well, if I'm driving on the LIE, it will assume I'm in a highway. If I'm driving in Manhattan, it will assume that I'm respecting Mayor de Blasio's 25-mile-an-hour limit. Or does it kind of looking at Waze and seeing if Waze tells me in my route what is the traffic? And then the next question is it looking for, I left Long Island at 3, and so I was going to hit the city in the rush hour. So does it consider that? Yes.
No, I just want to tell a story that just recently happened. I had an appointment, and my phone, I got a notification from iPhone that you have to leave 10 minutes early because there was traffic on the.
So you did tell your iPhone?
I think there was it's probably for my email appointment that they sent confirmation because I don't remember I was putting information, but I think it's sent.
I love the
my
question.
email to my calendar, and then the track location where I'm going, and I don't know, it sent me
Yeah,
notification.
I love the example because I have a set of slides we talk about predictive analytics, and it says that sometimes your telephone is freakish. It guesses what you're going to do. Meaning, for example, when it serves me a telephone number that I couldn't find, I go, what is this thing doing? Okay? But then I realized the telephone number of the guy was in the bottom, or it said, yeah, have you noticed when you message and say tomorrow or today, it highlights it? Yeah, it started trying to understand where it is.
On to Stephanie's thing, iPhones have programs called, I think, location services. So like, it keeps track of everywhere that you've been and how long you've been there and what time. And I guess it's for marketing purposes, but like you can disable it.
Yeah, you can
but
just
it's
turn
kind
it
of
off,
creepy
yeah.
to know like it's
Yeah.
always keeping track of where you are.
Yeah.
It's like,
I like this example too, because this is exactly what we were talking before about how does Google makes money.
Yeah.
Okay, that's valuable information.
And then new iOS, I heard they're allowing Siri to allow third-party apps to work with Siri. Now, so far, like they're only allowing Apple products, Apple apps.
And you know why?
Yeah.
Why?
For predictive service to work better.
Yeah, and the other thing is that there are other voice recognition systems like Siri that are becoming very good, maybe better than Siri. Actually, they're better than Siri. And guess what? Apple bought 2 or 3 voice recognition companies and predictive analytic companies. And basically they said, let's try to find the technology that already exists before we spend 5 years in the labs trying to develop this. And Microsoft bought a voice recognition company and goes on, this thing. It's pretty freaky, correct? Some of these predictive stuff. Yesterday I was startled about something that